Welcome to SkyTour LiveStream, and this is SkyTour LiveStream East. I want to welcome Don Harris from Tampa, and I want to welcome Marianne and Nancy as usual. Hey, babe, how you going? How's it going out there, all of you guys? I'm having such a fun time. I've got my Arizona clothes on, actually, so things are going pretty well for us right now. I'm just coming back from being sick too, so I'm my mind is still a little bit mushy and mush-headed, but don't worry. We've got a beautiful moon to look at tonight. And I've got Daryl with me. Hey, Daryl.
Hi, Mark. Hello, everybody. Long time no see.
I know it. It's been fun. I've had to. I only today got my voice back, and believe it or not, I'm supposed to do a radio show tonight from 8 to 10 on SkyTour Radio on KGRA Radio, but unfortunately, I was sick the entire.
Oh.
And there's our wonderful interruption. I asked Daryl to leave that in. I wanted to hear that kettle.
That's my kettle whistling. I'll be right back.
I love it. That's funny. Yeah, so I only just started to feel better today. My voice only came back today, and I haven't had any time to prepare a show for SkyTour Radio, and I feel so bad about that, and I'm really sorry. But I'm just hopeful that I'm over it right now. I mean, it's been really kind of an uphill slog with this. Daryl knows what I'm talking about because Daryl's been sick almost all winter, and he's not happy either with it,
Okay, thank you for your patience.
And we thank you for your support.
Yep.
This evening's SkyTour LiveStream is actually going to feature something new. I'm always adding to the capabilities and qualities of the experience for you guys that are watching. And what I've added is what's known in the business as a telestrator, but it's also, you might think of it as also like a whiteboard. So for instance, I can say to people, this section over here is where we do all of the telescope control. This section here is the dome ops with me. And this section here is the camera controls, and of course the center of the screen is where we see all the wonderful things. So I've added the ability now to draw on the screen and give us some kind of overview of things as we go along. I think that's kind of cool, and then of course I can get rid of it right away. I don't have any reason to keep it around. And Nancy, I'm sorry that you've been sick too. It's terrible. I did a talk out in Laughlin, Nevada a couple weeks ago. Was it a couple weeks ago? Actually, it was. I was out there from the 14th to the 26th. On the 14th, I arrived in Las Vegas, went down to Laughlin for the 15th through the 23rd, at which point I went back to Phoenix with Phoenix people that were there, including Marianne Robb, who was here in the chat. Hey, Marianne. And when I did that, I went out to the desert, and that's where I started working on SkyTour LiveStream West. It was just a patch of dirt when I got there, but in the intervening 2 days, it became a formed up square of wood and stakes, and then it became a concrete pad the following morning when a concrete truck drove 14 miles out into the desert to get to the site, which you have to understand, there's nothing between the main road, and where we are. So the driver really had to have what's a clean word to say that
GPS?
Yeah, there you go. GPS doesn't work out there. I mean, it does, but you got to understand that roads fork off on each other many times. So you might think you're on the GPS path, but unless the accuracy of your GPS is down to a few, like a less than a meter, you will not be on the right path. So you'll end up on the wrong road. And I did actually. The first time I went out to this particular location, I went down the wrong driveway, and ended up face to face with a guy with his gun and a bunch of mad dogs circling my car. I leaned out the window with both hands and said, "I'm sorry, I was looking for so-and-so's road." And he goes, "Oh, no problem then." He gave me directions. I'm like, totally, that was his friend. And I backed out, went right to it. Guts, that's a good way to say it. Carol, hello, Carol. And So I ended up getting to this location for SkyTour LiveStream West, and now I've actually gone in and out of it so many times that I don't need anybody's help anymore. I get there, and you know what you do? You make
breadcrumbs.
Yeah, effectively correct. That's exactly correct. But the breadcrumbs are made of saguaro cactus.
There you go.
You know, each one is unique. It's like fingerprints.
Yep. There's Senior Manuel and
that's right.
La Luna and you name it.
Yeah.
Well, you will name it.
Well, most of them are surrendering. You know, they have their two arms up, which implies a 200-year-old or approximately 150 to 200-year-old cactus.
Sometimes saguaros look like they're flipping you the bird too, though.
And they do. And there's one that I call the bird just for that reason. Hopefully you'll get out there someday, Daryl. I'm inviting everybody from SkyTour LiveStream to join us out there for at least one session if they can get to us. I think it'll be kind of a cool thing.
When the Greeks count time by kalends. We'll see someday. I'd like to see that.
That's funny. However, the pad that we poured, as you saw in the Facebook posts, is 11 feet by 11 feet in size. And I have developed a thought process for how we're going to make it so we can put multiple piers in this smaller 11 by 11 building. It was supposed to be 12 by 12, but it went down to 11 by 11 because of practicality and being able to do what's called screed the concrete, level it using a long board. The longest board we could get was about 12 feet, and we needed one slightly longer to be able to do a 12 by 12, and we didn't have it. So out in the desert, you make do. So the pad's 11 by 11, and to combat the issue of having this is a live shot, by the way, to combat the issue of having a 11 by 11 pad and still wanting to have multiple piers in there, I figured out a way to do that. The telescopes will be mounted on piers that raise and lower, and these are something that you can get. The pier is actually made in Denmark, believe it or not, but there are used ones available for very little money, relatively speaking. So this telescope will be mounted on a pier that will raise and lower. What does this do? This means that even if it's in the corner of the building, it'll still have an unobstructed view of all the horizons, because the telescope will simply raise up in the air by 30 or so inches and be completely clear of the walls of this roll-off roof observatory. And of course, it's very important to be able to bring that down before you close the roof. So I've built code into my program that runs the observatory such that it says I can't close the roof unless the telescopes are lowered and are shut off in their parked position. So I think that's going to be really cool, really neat.
Yeah, that's one of those things you only have to do wrong once to learn the hard way.
I know, but the telescope, the worst that can happen is the roof will not close because the telescope can't lower. And that's why I always have someone on site who can run out there and check it if needed, but there won't be that need, I hope.
I hope.
Well, I would never even open the dome unless it was something that was that we could do without problem,
Well, that's one of those things, that's like putting the reds in with the whites in your laundry. It only took me 3 times to learn that.
Hey, I've had pink clothes, and I said, all right, I got pink clothes.
Oh yeah, pink underwear, I'm embarrassed to say.
Oh.
And socks.
Yeah, well, that can happen.
Yeah.
Now, this is the view right now outside.
Actually, I felt pretty though.
I bet you did. Let me this is going to be, let me just take an exposure here. This is the all-sky camera that we have now. This will be installed out there at SkyTour West as well. This is the last frame in animation that I had this system put together for me. So I'll let this take its picture, and then we'll come back and check it out when we come back. So yes, this is the moon right now. Let's just take a quick exposure. 15th of a second. All right, and you can see that the telescope is performing rather well tonight. Look at that. Looks beautiful. Now, we do have a cast to the moon that's a different color. Part of that is due to the fact that I'm trying to get the moon to give up its details for us. All right.
Did you see that figure X of light in the shadows?
I did, actually, and I was going to ask you about that.
I think that's a known feature.
I think it is. You're right. This is the rims of 2 craters, and it shows up at only one particular point. For those that don't know what I'm talking about, I will highlight it for you with our new circle drawing and drawing capability we have within SkyTour LiveStream now.
Ta-da!
Ta-da! Yeah, this is a beautiful little feature, and that is a known feature. Daryl's right. Thanks for pointing that out.
Sure.
Because I was steering people to something else and forgot to mention that. But that's really cool.
Yeah, as Mark said, that's the juncture of a couple of craters where their rims are higher than their bottoms, and the mountain rim edges are sticking up in the light while all the rest of it's still down in the shadow.
Yeah, like this one and like this one. So they're like, the craters are right next to each other, so you don't actually see the rest of the crater. You can kind of see the rest of the. You can see part of the crater here.
Yeah.
I
think that's really cool.
It is. I'm glad I finally caught it on the stream, and we actually pointed it out. That's good, so we can go back to it. I want to say hi to Esoteric and Rascally Rabbit and Do. How you doing, Do-W? And I think I said hi to Marianne already, but I'll say hi again. And Carolina Sky, what's going on? And C&D Boy, Canada Boy, how's it going? That's right, Convoy. We actually saw a very large explosion. Not here in SkyTour LiveStream, but astronomy in general. And Blog Tornado, really good to have you with us. Thanks for joining and coming along. Remember, you can always you can join and then hit that bell to be notified when we go live. You might, in that way, you won't miss things like this. This beautiful, this X confluence of 2 crater rims. That's a known feature that Daryl said is true. And we have it there. And this is a photo that we're looking at right now. We just took. And we go down a little more. We have 2 more craters I want to show you. We got this one here. I'll just put a dot in it, and this one here. Okay. This one on the left is Stoffler. Okay, that's S-T-O with an umlaut, F-L-E-R. And this crater here, what is that crater? I just said it before. It's not Cuvier. Cuvier is right here. That's Cuvier. This one is Stoffler, and I'll tell you in a second, because I'm not giving up. I'm not giving up on this. Stoffler, and oh yes, that's right, Maurolycus, M-A-U-R-O-Lycus, Maurolycus.
See another light feature over there on the left where you are.
Right there?
Look, yeah, it looks like Bart's up higher. Next one up, right there. Looks like Bart Simpson's hair.
Okay. You're talking about this guy right here.
Yes.
All right. Interesting. Yeah, that does sort of look like Bart Simpson's hair, and it's like, nobody saw me do it. You can't prove a thing. That's cool. Neato. Yeah, we have lots of these Terminator apparitions that appear, like this string of dots that you see right here. This string of dots is, again, it's the interrupted high points of the rim of one of the craters, or it's one of the ridges in between craters. Pretty cool. Hey, Andy Morrow, welcome. I apologize for my voice. It only came back this afternoon, actually, not even this morning. It was this afternoon. Do-W, yeah. Eat my shorts, man. That's right.
Dude, I'd let you have some of my chicken soup. I got the stuff to make it this morning, but I forgot the egg noodles, darn it.
Oh.
I intend to make some.
Okay.
I've been living on soup this winter. And I'm still sick too. Jesus, this has been going on all winter long.
Yeah, I don't doubt it. I mean, it's tough,
Well, once coronavirus gets here, it won't make any difference anyway. The living will envy the dead and all that happy stuff.
Yeah. Well, I don't mind if you're eating and drinking tea. It's fine, Daryl. Not to worry. We like you anyway. So you're allowed to get away with stuff like that.
Yeah.
Now, if it was Amanda, on the other hand, well,
Hopefully Amanda shows up.
I know. I did ask her to join if she could.
I bet she shows up.
I hope so.
Everything's better with Amanda.
That's right. Oh, hey, Blog Tornado, you came here because of a UFO documentary. That's very cool. Oh, and they mentioned me? What did they say? And which documentary was it? And was it something good? Egad.
Mark, can you zoom in on the Terminator again?
Sure.
Maybe closer to the center, a little bit below center.
Yeah, all right. Let me just grab us a shot here, and we'll do that. Okay, so you want us to go above the X?
Those two big craters at the top.
Yeah.
Yeah, there. Now go to the right a little bit.
Yeah.
Okay, there they are. There are three of my favorite craters right there in the lower right-hand corner. Can you go over just a hair more?
Sure.
It's the dumbbell with another one laying over the top of it right there, just a little bit right of center.
Okay, so
there you go.
Yeah. Here?
And no, down below that, there's two craters, and it looks like they're connected by a bar.
That guy.
It's what I call the dumbbell.
All right.
No, not there. And then the third one up to the upper right, which is overlapping the upper one of the dumbbell.
So
can you ID those real quick? Because God help me, I've forgotten their names.
I could, but you just got to tell me where we're actually, which ones I'm actually looking at, because apparently I got the wrong ones.
Oh. Well, no, you're there. I mean, your pointer is right on the lower one right now.
The lower
And then
one.
there's like a little canyon or bar connecting to the, no, go down to the lower right, lower left.
Lower left, this one?
Yes, that's the upper half of the dumbbell.
Upper half.
Now, if you go to the bottom of it and follow that bar down,
like
there's
this?
the lower half of the dumbbell
you're talking
right there.
about this guy right here.
Yeah.
This followed by the, oh, okay, I see. Well, there's also the weird connection to these two.
Yeah. Well, yeah.
Okay.
Can you ID those? They have cool names, and God help me, I've forgotten what they are.
All right. Well, I'm gonna.
That's one of my favorite lunar features right there.
All right. Well, let me just figure out where we are now. So we're actually just below. We're just below this guy, right? So we're talking about these two right here.
Mm-hmm.
Okay. Yes. Cyrillus and Theophilus? No.
Theophilus. Yes. Yeah. Cyrillus and Theophilus.
This
and
is
then the
Theophilus.
Third... Huh?
I think this is the one that's Theophilus right here. The one that put the orange dot in, that's Theophilus. This is Cyrillus.
Yes. Cyrillus, and then what's the third one? The bottom one.
Katerina. This is
Katerina. Very good. Okay. Yes, I remember them now. Thank you.
Okay. Yeah.
Katerina, Cyrillus, and Theophilus.
Right. This area forms a really interesting, triplet.
Yeah, and I've long remembered that as the dumbbell.
Because of this shape here.
Yeah.
Yeah. I don't want to. I'm not going to overuse
really
this.
Jumps out
but
at you in the eyepiece.
It basically goes like this. Sort of like a little dumbbell thing like this.
Exactly. And then the one to the upper right is like one of the plates fell off or something.
Theophilus.
Cool. Theophilus, Cyrillus, and Katerina.
Yeah.
Now I remember.
In that
Thank
order.
You.
Yeah. That's right.
Can you show the people Messier?
Can we see Messier?
I bet you can.
I have to move over a little bit.
Yeah.
Let me try and see what I got. Oh, sorry, I got to get out of this. Sorry, I was in my tool. So we're talking about over here, aren't we?
Up a little higher.
Well, is that Pickering? Hang on.
That one has interesting ray on it.
See that one?
Yes.
Yeah, what is that? Is that?
I forget.
Okay.
It is sort of mindful of Messier, though. It has that ray projecting out one side.
Yeah, it does. Yeah. I'm trying to see which one that might be. Okay, so let me get organized here. Okay, so that's all right. This one is actually is this Facunditatis here or Nectarus? No, neither. Yeah, it is. This is Mare Nectaris here.
Okay.
Right, and that crater we're looking at is actually Rossi. This little crater right here is Rossi.
Cool.
With that really cool ray sticking off here, that one singular ray. That means a glancing impact, but note the crater is nearly round still. That's because of the way energy dissipates when something strikes. If you look at like when you skip a rock across the water, you'll notice, and I think this is where you wanted to go, right?
Yeah, Messier A and B.
Yeah, when you skip a rock across the water, you'll notice that the concentric circles that form where the rock struck, even though the rock's hitting at a glancing, shallow angle, those concentric circles are circles, actually, and not ellipses. So that's why craters are mostly round, no matter which way the moon gets struck, because the same thing happens at high impact speeds on the moon. And they're not all the same depth, and you can convince yourself of that very easily by simply looking at the Lunar Reconnaissance Orbiter Quick Map and doing the profile. Use the profile tool. Draw a line through, and you'll see that the craters are all vastly different depths. They're not all the same depth. It's pretty awesome. This is the one that he wanted you to see. Messier right here. Notice that ray structure. It was, again, a very glancing blow, and then it went zip. Now, depending on the speed of impact, the crater it makes could very well have been an elongated crater. At higher energies, though, at the typical energies of the strikes, the craters will all be round for the same reason that skipping stones make round little impact puddles as they go across the impact rings as they go across the lake.
Yeah. If you had a zoomed-in view there on the craters in Messier, there are actually two of them, and it looks like the asteroid, whatever, hit once and kind of skipped and hit a second time.
Yep.
And then left that big ray projected out the far side.
Yes, I'd like to know where it went, though, because it didn't end up in the crater, I don't think. It may have. You know. Well, not no gravity, but lesser gravity. Definitely a lot lower gravity, 1/6, in fact, of ours. So, yeah, that's pretty cool. I'm a big fan of the moon when that's all we have to look at, and and that's not all we have to look at tonight. But I will say, like I said, I am pleased with the performance of the telescope. It's showing us some details that I've never been able to see before with this telescope, because typically the telescope I use is more for deep space objects, and the moon doesn't show nearly as well as P&K space imaging can show. And I don't know if they're streaming tonight or not. Well, I hope they are, because they're just so cool. Hey, Daniel Whitaker. Welcome. Hi, Trish D. And Puda.
Hi, everybody.
Oh, see, you just say everybody. I have to go by their names. I want to see their names. I'm
trying to keep up here.
That's all right.
And Andy the Bra was very clever for what I called the dumbbell.
Oh, okay.
Yeah, I bet Andy watched a lot of Benny Hill back in the day.
I bet he did. I certainly did.
Me too.
Yeah. Benny Hill was a very funny man. Well, Blog Tornado, thank you for finding us after that, and I'm glad you saw the documentary that you said I was in. There have been a lot of them. I'm not sure which one that was, and it's okay that you don't remember. But I'm just happy you found us. So make sure you hit that bell so you can see when we're going to stream again. And we will be, if you remember this, we will be, we'll have our West Coast Observatory up. I'm hoping by April 30th. That's my ambitious goal. And I'm really hoping that'll be up and running by then. I solved a big problem today, and that was how the telescope was going to be mounted in there. And we are going to use what's known as a telescoping pier. The telescope is going to be down low, and it will raise up to bring itself just above the walls of the observatory, which is going to have a roof that rolls right off. So the telescope can hide out of the way, and then when the roof is off, we can bring it on up. I've been checking the accuracy of such piers because obviously anything mechanical can induce errors, and I think we will be okay.
What can go wrong will go wrong.
And there's Daryl with that wonderfully helpful comment.
Yeah, and usually at the worst possible time.
Yes, I'm very familiar with Murphy.
Oh yeah, me too. That was my job for 40 some odd years, was dealing with Mr. Murphy.
That's right, you were. Yep, you were. And you did a good job too.
Oh, I like to think so.
Well, you always said so.
Haha. Hey, there wasn't one person at 500 could do what I did.
Hey, you
I mean, if I was a baseball player, I'd be a millionaire.
Well, that's probably true, huh?
But now I just annoy people on the internet.
As the temperature drops, one of the things that we notice is that the focus changes on the scope, and I just have to come back in every now and then and adjust the focus. It's a common effect. Okay, that looks. I know you guys didn't really notice the change, but I sure did. Okay, so now if I take another picture at a 50th of a second, we should see. Let me just bring the moon back in here. All right, we should be okay. Let me see now. Yeah, look at that. That doesn't look bad. There's our X. By the way, as the night wears on, you'll see the X get thicker. If we can keep looking at the moon. Oops, wait a minute. I got a little issue for you that I didn't. There we go. Sorry. I didn't have it in the right setting. I apologize. Yeah, so that X is going to get thicker as the night goes on, as the rims of the craters become slightly more illuminated.
As the sun rises.
Mm-hmm. Sunrise on the moon takes a while because the moon does not rotate on its axis but once every month. And so that's why we see the same face every month, because it rotates exactly in sync with its orbit around the Earth. That's called tidal locking. We also notice that happens on a lot of planets that we see around other stars. That same process of tidal locking takes place. And tidal locking is, tidal locking is interesting because if we go to the red stars that we see, the stars that are, the low temperature stars, so to speak, then we see that many of the planets around these stars, to be in their habitable zone, they have to be very close to the star. So close, in fact, that Mercury, at its distance from our sun, would be in the frigid freezing zone of a star like one of these M-type stars we're talking about. And most of the planets around M-type stars are closer to the star than Mercury is to the sun. And that's because the stars are literally a tenth or even up to 100th of the output of our sun. So they're not as hot, they don't send out as much radiation, so you have to consequently be much closer to be in the habitable zone. So that all said, I think it's pretty interesting when we look at tidal locking, because a planet that is in tidal lock with its star will always have tropical noontime sun actually on the middle of the planet on the daylight side, and it will always have perpetual sunset at the sunset location, and then on the night side it'll be perpetual starlight. And I thought about something that would really be a great, incredible opportunity for real estate developers. Come see the land of the perpetual tropical sun. At the same time, you can sign up for a field trip to the sunset side, where you can explore and enjoy endless sunsets all day and all night, so to speak. And then if you're an astronomer, you can go to the nighttime side, sign up for a tour, and head to the dark side, where you can explore the universe. If you stay long enough, you can see an entire year's worth of stars, because these planets also orbit the star in a matter of days, not a year like the Earth. So you can actually do a 9-day trip or a 6-day trip or even a 5-day trip on some of these planets and see a year's worth of their stars on the dark side. You'd visibly be able to see the stars moving across the sky because the planet is moving around the star, not because it's rotating on its axis. That is cool. You know? Hey, I see Ronald is here. Hi there, Ronald. You know? Yes, sirree. So, Daryl, are you still there? Oh, Daryl's on mute.
Yep, sorry. Hi, yes, sir. What can I do for you?
I was going to ask you, because we're talking about the moon and tidal locking and so forth, but I was going to ask you, would you like to tell the folks what we were talking about earlier about what is coming up in the morning sky?
Yes, I would actually.
I'd love
Folks,
for you to
the moon is going to do some really interesting things here over the next few weeks. After full, well, if you get up early before sunrise, you can see them now. Mars is getting ready to overtake Jupiter and then Saturn in the morning sky. Mars was over in Scorpius, and it was actually in Ophiuchus part of that time. It was moving west to east night by night, and Mars has now moved into Sagittarius, and right over the top of the lid of the teapot. It passed it a few days ago, the star at the top. And Mars, Jupiter, and Saturn are all coming together in the morning sky. And on the morning of the 18th of March, the moon is going to be joining Jupiter and Mars all very close together, and it's going to make a very pretty picture. And then the moon will move on by the next night, and Mars will continue and pass Jupiter and catch up with Saturn a few days later. What is it? Mars and Jupiter are closest on the 20th. The moon is there on the 18th. And then Mars will be with Saturn, I think, by the 31st of March.
Wow. Now, that is going to be cool.
And it'll make a beautiful picture if you can grab it with your camera before sunrise. If you go out and look right now, maybe 5 or 5:30 in the morning, depending on where you are in your time zone, about an hour before sunrise, Jupiter is the bright white, kind of steady, creamy white one. And then Mars is maybe 10 degrees a handspan to its right. It'll be smaller, dimmer, and redder, but it's obvious. And then Saturn was kind of half lost in the dawn light, but Saturn has now risen due to our motion of the Earth around the sun. Well, creeping that 4 minutes higher every morning. That Saturn is now easily visible before sunrise also. It's probably the dimmest of the three, or it may be about the same as Mars, but about the same distance to the left of Jupiter that Mars is to the right of Jupiter at this time. And it's like they're just doing a slow motion dance night by night in the sky, morning by morning in the sky. And go out and look. It's beautiful, and it'll be even prettier.
I would hope that some of you can do that. For those of you that don't get up that early, well, see, I have no excuse. I mean, I can set up a remote camera to just take the picture at the appropriate time, at the appropriate spot in the sky, right? So I should be able to do that, shouldn't I?
You would think so.
Yeah. So.
But hey, nothing beats looking at it with, human camera eyeball Mark 1.
I know. Human camera eyeball Mark 1, that's right. Oh, yeah. Hey, Kathy, thank you for asking. I'm getting better, yes. Today actually was the first time around this afternoon I got my voice back. But I was sick when I was out west working in Arizona, but I'm getting better. I've highlighted this X here that's on the screen. This is This X is a feature that you can see when you have this confluence of two crater rims, one here and one here. And when they form like this, at a certain time of the lunar cycle, you actually see this X. So as the night goes on, as long as we can look at the moon, that X is going to get a little thicker in the sky, or on the moon. We'll actually see it as more of the moon is illuminated, because we're looking at moonrise here. Interesting too, when you look at this part of the crater. Let's clear this. When you look, let's just pick a crater. Okay, let's take, say, this crater right here, the one I just put a dot in. Okay, this one. Okay, when you look at this crater, okay, and on the shaded side here, the temperature is very, very cold. All right, but as soon as the sun hits it, those particles of the regolith, the soil, absorb radiation from the sun. There's no air to spread the heat, so it's literally only absorption and re-radiation of energy. That is why things will be warmer and cooler in space. So in the cool spots, it's minus, depends on conduction through the soil, but roughly minus well over 150 degrees and plus over 150 degrees in the sunlight, maybe more. Again, it depends, like I said, on the density of the area and how well the heat gets conducted through the soils and stuff. But it's pretty cool. And I'm really a big fan of I'm a big fan of that kind of study. I think I told you guys I made lunar soil for a TV show that actually conformed to the properties of real human soil, right down to the conductive properties as well as the static electricity properties. And that was a problem because, once that stuff got airborne, it settled on everything. And to this day, I'm still wiping lunar dust from a 2-year-old program I did off of things in my shop. So, and you got to wear a mask all the time whenever you handle it, because you don't want that in your lungs. So, yeah, we'll check this later.
Hey,
yeah.
Can I add something here?
Please do.
Darn it, I'm trying to paste it into chat, but it won't go. Mr. Computer's unhappy. The X has a name. The Lunar X has a name.
All right, what is it?
The Lunar X. Also known as the Werner X, with a W. W-E-R-N-E-R-X.
Yeah.
So the Werner X or the Lunar X. Light and shadow creates the appearance of the letter X on the rim of the Blantinus, Lacaille, and Purbach craters. We're lucky. The Lunar X is only visible for a few hours before first quarter.
There you go. And there it is.
So, hey.
So this is a very special SkyTour LiveStream. You'll notice, by the way, the X is actually a little thicker already, I believe. If I go back to an earlier image, let's take a look at an earlier image and see if we can see a difference in the X. Well, now you look at the X, I see there's a gap here. And let's go back to the current one, shall we? Let's go see. I want to see if it's changed that much. I mean, it will change. You'll notice it'll be noticeably different. Yeah, and this one, now you'll notice that there's material starting to fill in here. You can start to see some of the light is hitting here now. And I wonder if I go back again.
I see the same thing often here where I live. I'm about 15 miles or so east of Pikes Peak here in Colorado.
Yes, you are.
And when the sun rises, just like that, the sun hits the top of Pikes Peak quite a few minutes before it hits falls down in town here.
Yeah.
And what you're seeing, that's the very same thing, basically a mountain ridge sticking up in the sunrise.
That's right.
And if you're down in the dark, you're still down in the valley and you're not seeing it yet. But you can see the mountain ridge light up.
Yep. That's exactly right, man. Daryl, you are a font of knowledge. I'm so pleased that you are here with us.
Oh, well. I want to raise.
You know what? Me too.
Yeah, there you go. Anyway, that's just really cool, I think.
Yeah, well, we caught it. We had a few hours before our first quarter to catch it, and we did.
Uh-huh.
Yep. I think
X marks the spot.
That's right. That's right.
One other thing's happening in the evening sky right now, too. If you have been going out and looking southwest or more west-southwest after sunset, you have surely noticed the planet Venus. It's brilliant. It's the third brightest thing in the sky after the sun and the moon, and it's hanging up really high, almost in the west now after sunset, and it's not setting until after 9 o'clock at night here now. That's Venus is coming around the far side of the sun. As we look toward it, it looks like it's that car in the left-hand lane that's coming around the curve behind us and catching up with us.
Yeah.
The same sort of thing is happening with Venus now, that it's called greatest eastern elongation. And that's when Venus will round the corner on its orbit as we see it from Earth, and then it's going to start dropping night by night instead of rising. It's going to fall faster and faster each night, and it is going to, greatest eastern elongation, I want to say, is March 10th. And then it's just going to drop like a rock out of the sky. And if you can see Venus in the telescope, about now, it's going to look kind of a lemon shape or almost half lit like a first quarter moon, but in reverse because it's getting skinnier every night. And you'll see that crescent get that half Venus turn into a skinnier and skinnier crescent every night.
That's right.
And finally, it'll be about 1/30th the size of the moon in the sky, about 1 arc minute in diameter, and then it will pass between Earth and the Sun. So-called what is that? Superior conjunction? Inferior conjunction.
Yeah.
And then Venus will pop back up in the morning sky.
Yep.
And that's going to happen. I think, again, the elongation is on the 10th, I want to say.
I don't know that date for sure, but I don't know when the elongation is going to be, but greatest elongation.
Yeah. 10th or 20th. Okay. I'll have to look that one up.
All right.
But anyway, it's another really pretty thing to watch, and it's dynamic, and you'll see it change night to night, especially once Venus rounds the corner there and starts dropping again.
Sure. I want to say hi to D. Smith, by the way, who thought you was going to sneak in here and not be noticed. I noticed everybody like Genghis. Genghis snuck in here and thought there would be no notice taken, but I caught you. Good to see you guys. Yeah, there we go. So now, like I said, we'll come back to the X. I just think it's pretty cool, don't you?
I do.
I just think it's probably one of the most cool things. I'm glad we got a chance to actually catch it, And for a live shot, I mean, we can just do a live shot of it like this, and if I just grab a live view. Okay, you can see the X right here. Okay, or with this guy, you can see right here that there's an X here. Yeah, right here. That's our X, which is kind of cool. And if we watched it all night, you'd see it change.
I'm glad we saw that.
Yeah.
Maybe we'll get to see it again before the night's over.
Yeah, we're gonna, because I'm not gonna go anywhere. And for those of you who haven't noticed or did notice, we do have a new feature. We do have the ability to draw on the image now. That's the typically that's called a telestrator, but we're actually I actually changed up all of the methodology by which I'm bringing this to you. So that's something I did this week after coming back from Arizona, and I've settled in on the final approach I'll be using when I'm out there, or when we're running the telescope out there. Hi, Tara. Tara's here too. Tara had an extra special event occur when I was out in Arizona. She got to see the SkyTour LiveStream West site. Now, Tara, for those that don't know, she actually helped me edit my book, The Populated Universe, which you guys can get on Amazon if you want it. It's a book on exoplanets and the search for extraterrestrial life, and it gives you a scientific basis for why your belief that we're not alone is probably correct, right? And so she helped me edit the book, and so I wanted to have her come check out the SkyTour LiveStream West site, and she did. And I think she had a good time, except for the part where she was getting chased by coyotes. But you know what? Whatever. How bad can it be? You know. So, Marco, how you doing? Nice to see you. Daryl, you're here with me. I see you. So, I think that what we'll do now is we'll come back to this. What I'd like to do is check out where our telescope is pointing. You can see that it's pointing pretty much up there. So that'll give me an option to take a look at something nearby. Now the moon is going to be in lower and lower quality for us because it's going to be it'll be setting eventually, but it's not setting yet. Hold on. I want to get over where I belong. Here we go. Okay, so you can see now it's 45 degrees up, and we can actually zoom in on it, and the planetarium program will very nicely show us our moon. Very well.
Sitting between Aldebaran and the Pleiades,
too. Pleiades, that's right. That's right. Yeah. So what I wanted to do was to see if we can check out the Pleiades while we're here. So
that's a great idea.
Let's go right now. So watch the moon here in the live view. Off we go. We'll see if it'll work because I'm sort of in a location where we might not be able to, well, maybe. Depends. If we can see ATIC, then we can align on it with the telescope, and then from there we'll know exactly where we're supposed to be going. So let's go check it out in our main view here. Let's see. If we don't see it, it means that we're not aligned. I should say, if we don't see it, it means that we're not able to align on ATIC because the alignment scope can't see it, which is possible. The dome shutter causes issues that we will not have with the new observatory. And it looks more and more like that's the case here. Yeah. Yeah, we can't. It didn't work. That is what happens when we do this.
Bummer.
Yeah, I just got to go move the telescope dome, that's all. So you want to take over for a minute while I go do that?
Yeah.
All right, I'll be right back.
Okay, you have to put up with me for a minute or two, people.
Oh, stop. There's nothing wrong with putting up with you. I'll be right back.
Okie it's interesting, Mark working on and talking about the new Arizona Observatory. Us having similar interests, of course. I don't know what triggered this, but YouTube has been offering me observatory construction videos lately, and I watched several, and they're pretty amazing to see. Some of these are up to like meter class instruments. I'd hesitate to call them amateur instruments at all. Like meter class, like about 40-inch aperture telescopes, and it's amazing to see all the thought and design that goes into these things and the differences in designs. If you ever look at Astro Backyard, he's the Canadian astronomer imager up in I want to say he's in Ontario. He works out of his backyard. He just drags out a telescope and sets it up in the driveway usually. But he just took a trip to L.A., and they went out somewhere, it looked like toward Joshua Tree or someplace out in the desert east of L.A. And, I mean, it's like a little astronomy, if not a city, a village out there. Just observatory after observatory all lined up. Looks almost like one of those storage places. You know, you go rent a unit, they're just lined up like dominoes. And there's roll-off roofs like Mark is building, and there are domes and everything in between. It was a really cool video. He didn't get to stick around long enough to make full advantage of it. He had to get back and catch a plane back to Canada. But still in all, it was a really cool video. Maybe if I ever win the lottery, I don't know. Golly, it'd be nice to have a 40-inch telescope out in the backyard someplace. And he's back.
Yeah, well, of course Andy's back. I saw him in the chat. Okay, so we had two things against us. Number one, the Pleiades is almost behind the house at the moment, so we're not going to see it.
Oh.
Yeah, so that's a problem. So I've done the next best thing. I've moved this over toward Orion. And I'd like to go see if we can check out Betelgeuse. It is brightening, so let's make sure. With this Mr. Rogers' Neighborhood music playing in the background. Okay.
Yep, Betelgeuse is brightening now, and we may have to wait next time around for a supernova. Amanda and I had an interesting talk about that a night or two ago, actually.
You did?
Yeah, we did, you know, the Betelgeuse brightening thing, and she asked, you know, well, does that mean, you know, what about the supernova people speculated about? And,
yeah.
You know, I would guess any supernova would have to happen when the star is shrinking at that point. It's Betelgeuse is a variable star, okay, people? It pulses. I think it takes about 430 days for a cycle. And when Betelgeuse dimmed so much here just recently, well, it was like at the low point of its cycle, at its dimmest. And she wondered, you know, at what point would a supernova happen? And I would have to think it would be when the star is collapsing.
Yes.
And I would guess that would, you know, that means it's getting smaller but more compact, and therefore, you know, the increased compactness of it would be what would trigger the supernova eventually.
Well, there's two ways that supernovae occur that we know of, really, and one is the type 1A supernova, which is where you have a binary star system with a regular star and maybe a giant star and a white dwarf. And as the white dwarf is orbiting the giant star, you know, after the white dwarf goes through its phase of, you know, being a star that actually was, you know, maybe about the sun size, maybe a little bigger, it swelled up. It was a red giant for a while, and maybe some of its mass bled onto the other star. But then once it shrinks down, it's possible that the other star and the white dwarf have gotten closer to each other because of the material between them that causes the angular momentum, that is, of the two objects to change, and thus they might spiral toward each other, which is why black holes collide eventually. They're not just coming whipping out of space. They've been orbiting each other for a long, long time. And over time, their orbits decay into each other, which is what happens maybe with a large star, say, in a white dwarf. Well, when that large star starts bleeding material onto the white dwarf's surface, several things happen very quickly. All that material on the star's surface, which is mostly carbon and oxygen atoms on the surface of a white dwarf, that material can explosively ignite, and that can disrupt the star, and that's a supernova. The star then gets destroyed by that. The other way, and that's not Betelgeuse. Okay, the other way, and this is Betelgeuse right here, the other way that can happen, we'll do a 6-second exposure at 5,000 just to kind of show you the field. The other way it can happen is something called core collapse. And that's sort of what Daryl's alluding to. A core collapse supernova is one where the star, used to burn hydrogen, or fuse hydrogen to helium. When it stopped, it began fusing helium into carbon and other materials, and it began to swell. When it became a red giant, it had all these shells of other material that was being fused near its core. But when all of that stops, the outward pressure pushing out, which held it up basically like a balloon, all right, stops. And now the gravity of the star just comes rushing and pounding down on the core and from all sides. And that core collapse actually takes place in the core, where all these shells collapse onto each other. And that can happen in, estimates are about 1/4 of a second. And when that happens, it's instant. It's effectively, you don't even see it coming. The star will just suddenly just wink out of existence, and then all of a sudden it's a massive cataclysm. One of the biggest explosions in the universe. So the core collapse supernova is by far the more interesting one, because we get to see these really cool expansive clouds of expelled gases that were once the envelope of the star. And for instance, the Veil Nebula in Cygnus, when we look at the Veil, the Crab Nebula that we got some beautiful photos of one time this past season here, it was just beautiful, and those are supernovae. And we even actually imaged the supernova in M77, a galaxy far, far away, where Star Wars took place. No. You remember that, Daryl? I think you were the one that pointed it out to me, and we went there and we saw it.
Yeah, I think so.
Yeah, in M77. Well, now we have Betelgeuse, and Betelgeuse is going to undergo a core collapse variation of the supernova. And so when we look at this, let's actually, just to show you what we're looking at, I want to, and plus this will test the system. I'm going to do 25 seconds at 5,000. I have an auto-guiding system that's now in the system here, as you know, and I tuned it earlier tonight, and I want to see how we're doing, because I haven't taken any long exposures yet. So we'll see. If everything is a round dot, we're golden. If it's not, then there's some adjustments that need to be made.
Mark, Genghis asked some interesting questions, and I think you and I talked about this recently.
Okay.
When Betelgeuse dimmed, was it contracting or expanding? And
Yes.
if I remember correctly, you said that it should be brighter when it's expanding because it has greater surface area to radiate.
That's correct.
Hang on just a second. Sorry.
It's all right.
Live radio, folks, or live streaming. Okay, and that was what you said, was that the, Betelgeuse is brighter when it's bigger because it has more area to radiate the radiate the light.
And let's just say why. The luminosity, or that intrinsic brightness we're talking about, is related to the radius of a star and the temperature of the star. Now, as the radius increases, then the luminosity goes by the square of the radius. So, if it's 4 times bigger, it's 16 times brighter, kind of a thing. Yeah. But it goes by the 4th power of temperature. So as the star shrinks, it should get hotter, and the luminosity should also increase. So it's possible that it'll just end up being a wash, all right, where it does get smaller, and thus the luminosity should drop, but it's also getting hotter. But because it's in a smaller package, that hotter temperature may affect the luminosity in such a way that it's sort of an even trade-off. Maybe not. But I think that, when we saw Betelgeuse dimming, when people were saying that was probably a supernova coming, well, it could have been a difference in the way it was behaving that could lead to a core collapse supernova, but there certainly wasn't a core collapse. Because if it was a core collapse, you wouldn't even know it was happening. It would just suddenly just be gigantically bright in the sky. It wouldn't give any warning, so to speak. A star doesn't it's not like earthquakes, where you get harmonic tremors before the earthquake, and suddenly you know that an earthquake is coming, all right? Even that isn't even an exact science. Well, Betelgeuse here would just end up being there one night and not there the next. It would, or not, I should say that, but it'll be a much brighter object the next. Actually, if Betelgeuse went supernova, the only thing that would affect the Earth is the fact that its light would be seen during the daytime. But this is not new to the Earth. We saw this before. Not we, as in all of us living, but Chinese astronomers in 1054 AD. They saw the new star in the sky, Daryl, you know. It was the Crab Nebula. And that went supernova, leaving behind a little lighthouse of a star with hot spots on its surface. And that star was a neutron star spinning very, very rapidly with these extremely hot, highly energetic, highly radio active sites. And that was what we call a pulsar. A very special kind of neutron star. So
spinning 30 times a second.
And that's not even the record. Imagine a star the size of Manhattan Island spinning 30 times in 1 second. I mean, can you imagine the amount of gravity that's needed to hold that thing together? And that's not even the worst. There's another pulsar out there that is about the same size, because all the pulsars are about the same size. And it spins over 700 times a second. Is that not just astonishing or what?
Absolutely.
Yeah.
I mean, that's like that's like World Wrestling Federation. That's a superstar.
That's right. That's
no pun intended, but
no,
you know what I mean.
It is definitely the supernova of the superstar supernova. That's correct.
Hey.
Well,
going back to Betelgeuse a little bit, folks, some of you may have seen this. It was about the same time, I think, when they announced that Betelgeuse was brightening again. A couple of recent images of Betelgeuse were released. The one showed the actual star, and they were talking about how lopsided it was. It was not spherical. The second image was more of a wide field, and they had an occulting disc covering the actual star Betelgeuse. But they did that so they could catch all the clouds of dust around Betelgeuse, which have been emitted by Betelgeuse.
Yeah.
And the two pictures, they're just amazing to see. The second one in particular. And this could get back into the dimming too. There's some speculation now that what was making Betelgeuse dim so much wasn't that it was inherently getting brighter or it wasn't getting dimmer, but that it was being obscured by the huge clouds of dust that it has emitted as such a late-stage red supergiant star.
Right, which does also indicate to us that Betelgeuse is undergoing changes in its intrinsic behavior. So it doesn't mean that a supernova is going to take another, million years. It's not going to be that way at all. In fact, it's possible that it could go supernova within 10,000 or 100,000 or next week. You like those? You like those odds? I mean, that's welcome to the universe. We don't know the universe as well as we think we do. And most of us know that the universe is something we can't understand at this point yet. I do want to take a moment to answer a question that I saw. Ronald asked the question of if the Crab Nebula, now we only see the supernova remnant, can we tell what it was before? What kind of star? Well, the nice thing about these supernovae, Ronald, is they can only be one type of star, relatively speaking. There are some caveats, okay? But for a supernova like we saw there, these supernovae are generally hot young O stars that will end up obliterating themselves in their later lives. We know that Betelgeuse, for instance, is now a red giant. But before it was a red giant, it was on the main sequence. That is to say, it was burning, fusing hydrogen into helium normally, but it was a very massive star. So the thought is that Betelgeuse was probably one of these O-type stars as well, probably like Alnitak, which is the leftmost star in the belt of Orion. And that's an O 9.5. So remember, you have the O0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's an O 9.5, so almost a B type star. And then the other question then that Kathy follows on with, which I think is really pertinent, is, well, then what's a quasar? you hear about all these weird, strange objects. Now, quasar stands for quasi-stellar object, and that means somewhat like a stellar object. What they are, they're objects that we see well beyond the Milky Way. They're not in our galaxy. They're in other locations far outside our galaxy. And they almost look star-like, but they give off a very strange spectrum. That is, their light tells us things that we just find pretty impressive. Namely, that there's a lot of radio waves that come from these quasi-stellar objects, these quasars. And they have a spectrum that is very distinct from other objects out there, making them their own class of object. Now, the other thing about quasars, which is really kind of interesting, I think, is that we don't know literally exactly what they are. Could they very well be perhaps the strong cores of galaxies, and we just don't see the galaxy around it because much of the gas has been removed or dissipated somehow? It's possible these could be the active cores of very, very distant galaxies. We've seen some very strange galaxies. We've seen galaxies that actually look like rings. Remember the Ring Nebula? Imagine that the central star in the Ring Nebula is the rather fuzzy nucleus of a galaxy, and then the Ring Nebula itself is actually stars and gas and dust. That's a ring galaxy. And ring galaxies probably form by collisions with other galaxies. Some of the dynamics, if you look at the orbital kinematics and the dynamics of these, you can actually see that galactic collisions sometimes will cause rings to appear. They're temporary transients, but somewhere in the process you would expect to see a ring-looking feature. And sure enough, we get that in the collisional analyses, So ring galaxies are cool. But again, we only see the active center of the galaxy, and the ring might be less visible. So it could be that when we look at quasi-stellar objects, we're actually looking at objects that are just the central active cores of very, very distant galaxies. And that's not the be-all, end-all answer to everything. Okay, there's more possibilities here, and mine is just one of a few. But for the most part, that's kind of the standard thought process now on what we see when we look at Betelgeuse. Before it was, I'm sorry, not Betelgeuse, but the Crab Nebula before, and quasars that we talk about. So that's to answer those two questions for you. If you have any more, let me know.
Mark, Daniel Whitaker is asking about hypernovas. Would you care to describe those as we understand them?
Yeah, hypernovas are really strange beasts, and we say as we understand them, but we only saw a couple. We haven't seen too many. I mean, there's one that's called a kilonova, which is even greater, I think, than a hypernova. But we saw one kilonova too. I mean, so a hypernova, if you can imagine a nova that makes a supernova look like a child in kindergarten. Okay, the hypernova is something that is puts out more energy than we can even imagine is possible. So there's a thought process that goes along with what a hypernova might be, and it usually involves interaction of more than one star. We know the biggest O stars there are, and when they blow up, they don't do anything that's going to be approaching this hypernova state. So it's possible that there is more than one star that is engaged in the process of creating the nova. So when one goes nova, perhaps there's a second one nearby that's also induced into being disrupted, as we say, and going nova, supernova. So there's that possibility. Now, what's really going on in there? Well, that's a good question, because we don't really know. We've not ever really been able to study and examine, hyper and kilonovas very well.
Yeah. Well, after after a while, you start running out of superlatives. I mean, there's novas, there's supernovas, there's kilonovas, and there's hypernovas, and we're still learning.
Yeah, that's right. you know, and any one of the nova events can kill us. You know, if it was close enough. For instance, if Alpha Centauri went supernova, which it can't, but let's just say something came along and caused Alpha Centauri A, remember it's a trinary star, meaning 3 stars all orbiting each other. The main components are A and B, capital A, capital B, as we talk about on SkyTour Radio. Capital A is sort of like the sun. Capital B is a little bit different from the sun, but similar. And they're orbiting each other on a scale, I think, of many tens of thousands of years. But let's suppose something came through that system, a massive star, some other thing, and it caused the two to collide with each other. Now, there's a chance that one star would be absorbed into the other. There's a possibility. But you have to understand that stars are very fragile in the way they produce their energy. They're very distinctive. They have these shells of energy, shells of gas and so forth that they are fusing into other elements. The slightest change can cause massive changes to the system. So the chances that two stars can, quote-unquote, collide with each other and just be sort of absorbed into each other. You know, this isn't like soap bubbles where you can kind of push one into another and see how they get to make a bigger bubble. It's not like that at all, because stars are doing very specific things all the way to their cores, right? In very distinctive, in very distinctive ways. You can't have more than one core of a star. If you push two cores near each other, then that's going to change the whole dynamics of the system of the two stars. So there's no way that those two stars would get through this without being disrupted. And if they did that, then perhaps one star would be disrupted and the other would be obliterated as well in the process. If that happened at Alpha Centauri, 4.3 light years away, then we might consider that our time here on Earth is up. And at 4 years later, when the light actually made it to us, we'd see the light. We'd see that Alpha Centauri was changing radically. And we would see an expanding cloud of gas, indicating maybe that the stars were disrupted. And if we saw that, then it means that over some period of years after that, we would get hit with the material that may have come from those stars. Now, we also have the other more deadly immediate results, and that is deadly radiation that could go the 4 light years and probably do some serious damage to our atmosphere at the very least. So it could affect us here if it went. But of course, Alpha Centauri cannot. There is nothing that's going to be colliding with Alpha Centauri, not at least while we're heading toward it. And we are actually, it is getting a little bit closer to us, but so is Barnard's star, the second closest star to us. And at some point, Barnard's star is going to be just a little bit closer to us than Alpha Centauri. Barnard's star is this like red dwarf. And by the way, has a planet around it. So there's a lot of stuff on the astronomy front here that we're going to be talking about. You know, we're planning stories. Amanda has put together some wonderful stories for us to talk about. Daryl's brought up some cool stuff. I've dug up some things, and Bill, New York Skywatcher, our wonderful producer for KGRA, has also thrown a number of stories into the ring, including one that we're probably going to talk about on the next SkyTour Radio, which will be next Sunday, not tonight, obviously, because I'm here. And that next discussion will be all about the Alcubierre drive. What's that? That's the warp drive. A warp drive that a few years ago seemed like just a preposterous thought problem created by Mexican astrophysicist Miguel Alcubierre in 1994. But today, it seems like it's actually somewhat plausible. Being able to get to Alpha Centauri in about a week, rather than the 12,000 years it would take with our current technology. And it seems more doable now. I think that this is I don't know what to say other than we're moving forward. We're making our way. We're going to be one of the galactic civilizations eventually. You know. And no, I don't think we're going to destroy ourselves. No, I don't think we're going to ruin ourselves. I think we're going to get our act together eventually. And that's not just wishful thinking. We have to do this if we're going to survive as a race. So.
Ronald just said it, so I don't have to.
What'd he say? Shut up, Mark?
No, Mexican warp drive. Like a lowrider warp drive or something, I guess. Shame on me, shame on him.
Oh, that's funny.
Lowrider warp drive has a nice ring to it, though.
It does. I mean,
maybe we're onto something.
Yeah, we'll call it the Wave Rider.
There you go.
Yeah.
Should say two of the best supernova candidates in our part of the galaxy right now, in our neighborhood. One is Betelgeuse, and the other, I suppose, would be Antares.
Yes.
It's the heart of the Scorpion. It's in the morning sky right now.
We'll see that in the summer.
And, you could draw comparisons between Betelgeuse and Antares, I think. They're both red supergiants. They're both old. They're comparable distance away. And they think, generally speaking, that Betelgeuse being, for instance, 700 light years away or whatever it is this week,
whatever it is
probably
this week.
too far away to do us any harm.
Yeah.
So we should be pretty cool in that regard.
Yeah, Betelgeuse won't hurt us. Even if it was only 200 light years away, it wouldn't hurt us. It really, when we start getting less than 10 light years away, then you got to consider the possibilities that, maybe some type of residual radiation can hurt us. Now, it may not hurt us as beings, but what it could do is harm our atmosphere.
Yes.
And we don't want to see our ozone layer get stripped away by high energy radiation. That would be a problem. Yeah. So if you notice, by the way, I'm in Orion now, and I've gone from Betelgeuse up here at the top. I've come down to Alnitak, which is actually the type of star that we think might have been Betelgeuse before it became a red giant and ran out of all of its hydrogen. Alnitak is an O 9.5 hot blue supergiant star, and its destiny is to become a supernova. And Alnitak is only just about 4 million years old, and it doesn't have much longer to go. And I've talked about this before. When Lucy, the first hominid, was wandering around in Africa, that's Australopithecus afarensis is the name of Lucy. Lucy could have looked up in the sky and seen a blue giant star where Betelgeuse is now, and not see anything in Orion's belt other than perhaps Alnilam. Or is it maybe Alnilam or Mintaka? Alnilam's the middle one, Mintaka's the right one. I think Alnilam is the only one that might have actually been there. So it's kind of cool. To think how throughout the history here on Earth, the sky has changed dramatically. And it has. Alnitak was born after Lucy, who has long gone. So I think that's actually a very interesting possibility to think about. I like doing that stuff.
Mark Terra asks if Sigma Orionis is visible, and of course it is. Could we take a look toward it whenever we're done with Alnitak?
Yes, as a matter of fact, we can. That's a very prescient of you, Tara, to ask about Sigma Orionis, because it's right down here. Where? Well, it's sort of down in this way. We'll get there. All right, it's down there. We're not there yet.
Show off. Mark has a new toy.
I think it's very helpful to be able to point stuff out on the screen by, saying, well, what are you looking at?
Oh, it is. Yeah, I wish I could do it too.
Well, I'm sure that we can figure out a way for you to be able to do it with us. And I'm going to get a tablet too, so that I'll be able to, I'm a lefty. Okay, so remember what they always say, only left-handed people are in their right mind. Turns out that left-right brain thing is really kind of a myth. It's a misinterpretation of what's actually going on. Really what it means is that when you're doing tasks that are analytical, all of your brain is engaged, but different parts. Okay? When you're doing tasks that are creative, all of your brain is engaged, but different parts still. So It's just a different distribution of work that the brain is doing. Well, anyway, enough about the brain. Let's take a look at dropping us here. We're going the opposite direction of Sigma Orionis right now, because what I want to look at, being Mr. Show-Off, is something that's right here. And I think you know what that is, Daryl.
Flame Nebula.
Hey, you are smart.
I've been here before.
He is smart. Can he make it go?
I'm
Yes.
a lefty too, people, and
That's right.
I believe in the, we're the only ones in our right minds. So there.
Ay. Now the moon is still up, so as we do this, we won't see a very, very eloquently laid out flame nebula. It's going to have some light pollution from the nearby moon. Terry Groff is in the house. Terry, welcome to SkyTour LiveStream, man. Terry's one of my good friends from Texas. He's the man. And it's really good to hear from you, Terry. I'm glad you're here, man. Thanks for joining us. I hope you actually did join SkyTour LiveStream and then, hit the bell so you can know when we're going to do this again. That's really kind of cool. Yeah, there we go. You can see the flame, and this is on the top here. This star will be supernova someday. It also has a companion. It's a multiple star system, so the fate of those stars is also going to be in question as well. So now let's go back to looking at. We're going to Sigma Orionis now. This is for Tara Deulis. Here we go. Let's drop down. And we should see it showing up right about here.
There you are.
Yeah, there it is. That's Sigma Orionis. Daryl, this is one of your favorite stars, right? So why don't you tell people about it?
Absolutely, it is. Sigma Orionis, it's a multiple star. It's just beneath the belt of Orion. It is absolutely stunning to look at in the eyepiece. I mean, there are stars orbiting stars, or appearing to at any rate. There are several members of Sigma Orionis, though. And Sigma Orionis, if you've ever seen the Horsehead Nebula, it's actually the red clouds of hydrogen that silhouette the black horsehead. Those clouds of hydrogen are being energized, causing them to fluoresce by Sigma Orionis.
Mm-hmm.
And it's just stunning to look at in the eyepiece.
Well, and in this eyepiece as well.
Well, okay. Sure. Hey, I'm the visual guy,
I know, and I think that's all good. Yeah, this is Sigma Orionis. Sigma Orionis is, again, a very, very young hot star system. It's also, you'll notice, a little bit of a glow to the left side over here. And that glow really carries on over here. You really can't see it too well because the moon's out. But Sigma Orionis is responsible for illuminating and causing to glow a vast cloud of hydrogen. And that vast cloud of hydrogen, if I can show you where that is, we'll go back to here and bring up this. If we go look at where Sigma Orionis is, okay, this is Sigma Orionis right here. Okay, and notice I'm not going to use my new toy because it's going to be too cluttering here, Daryl.
Oh.
So here's
go ahead, knock yourself out.
No, this is Sigma Orionis right here, and it's such a bright hot star. It's actually illuminating and causing the glow. This red cloud of gas is mostly hydrogen, of course. And it just so happens there's this dark nebula that has a little tongue of black dust that is sticking out over this red backdrop. And this is dark dust. But what's back here are the hydrogen atoms. And they have been excited to glow by Sigma Orionis right here. So it's really quite a fascinating location. Everything in space that's glowing has some other star in the area to thank for the glow. And we've talked about this glow before. It's actually called atomic excitation, ionization, and recombination. What? Basically, hydrogen is a very simple atom. It has a hydrogen nucleus, which is a single proton, and it has an electron. But if you add a lot of ultraviolet radiation, that electron will bounce right up off the atom and literally be free of the atom momentarily. That's called ionization. Now the atom has a positive charge because the electron is +1 and the proton is +1 and the electron is -1. Take the electron off and you got a +1 charge left over. So it means we have a positive ion of hydrogen that's floating there for a brief moment. Then the electron, colliding with other electrons out in this location where this is happening, loses some energy and it begins to fall back into the atom. That's called recombination. And as it falls back into the atom, it falls to discrete energy levels. If you look at these little blue lines, you can think of it like a hydrogen atom. You have one level, second level, third, fourth, and fifth level, etc. Well, the atoms, when the electrons recombine, they drop into these discrete energy levels like these here, okay? But most of them drop to this position right here, which is called n equals 2, if we had a 1, 2, 3, 4, etc. Most of them drop to n equals 2. And when they drop into these energy levels, they give off some light because they're releasing energy. And the energy of an electron is in the form of light when it releases it. So at n equals 2, guess what? The light is red. And that's what we're seeing. That's what we see when we see this glow. It's the n equals 2 transition, we call it. The hydrogen alpha transition. And that's the color, for instance, that the filters on our telescopes at SkyTour LiveStream are tuned to seeing best. And so we get to see all these things like nothing. And Daryl, you remember when we first tried the filter we're using now, it just literally leaped out at us how much better it was than the others because of the way it would let in the right light we're looking for. Remember that?
Absolutely. Yeah, it was a huge difference from the last filter to this filter.
Yeah, we actually see more by blocking some of the light. Think about that. By blocking some of the light, we actually see more. Because we're actually blocking some of the light that blocks the fainter light and allow the fainter light in. So yes, that's this region, Sigma Orionis. So I hope that, Tara, that this is good enough for you. If you require more information, let me know, and I will send Daryl to give it to you. No, I'm just kidding. I'll do my best, as he will, of course. Daryl's always good at this stuff, and I try to be. But,
Me too.
yeah. So,
I have seen the horse head exactly once in my life. It was using, I want to say the guy had a hydrogen beta filter. And it was on, I think it was on a 13-inch telescope.
Okay.
From a dark sky, and could just barely see the horse head.
Wow.
But I got to see it.
Well,
that's one off my bucket list.
Here's what we're going to do. We're going to try to do, even with the moon out, let's just see if our filter can deliver just any type of a semblance of the Horsehead Nebula. We're going to go to 25,600 ISO. I'm giving the telescope time to acquire a guide star, and then we're going to do a 30-second shot. I was routinely doing 2 and 3 and 4 minute shots the other night, just as testing, and the telescope performed really, really quite well. So you're going to hold on to your horses, folks, and hold on to your hats, because we are going to have an amazing sky in Arizona. All right, so we're starting this exposure here. 30 seconds. We have the well, let me do my little toy. Okay, we have Sigma Orionis over here. We have the horse head right about here. We have a star that has a interesting little reflection nebula right here, so be looking for that when this comes back. All right, yeah, and this could be any color, by the way. I could make that red too, just to help you with with your night vision.
I want one.
I want you to have one. Okay, and let's see how we're doing with the guiding when it comes back. I haven't tuned it yet. I've only just taken a few pictures today. In fact, the longest one was Betelgeuse just moments ago, so we'll see what we get. Let's see what we get. All right, it's ready. Hey, look at that. The guiding is good. And we can kind of see the horse head, and I'm gonna draw around it for you just so you can see it. This is not because I want to play with my toy. This is because it's really the only way to show you. I think it's right here. Do you see that, Daryl?
I see something.
Yeah. Well,
I think I see something.
Well, with the moon out, it's kind of hard.
Yes.
Yeah. With the moon out, it's hard to see it. However, you can see this subtle red glow right here. Okay.
I almost want to say it's more up higher and maybe a little to the right of where you were pointing at first.
Think so?
Yeah, up.
Oh, maybe it's this.
Yes,
Holy
exactly.
cow. I think Daryl's right. Okay, so for those of you that are confused, like I was, this is the horse head right here. You can see it inside that little circle. Okay, and the shape of the horse head is pretty clear right there. See, now that you said that, it's clear. And you can see the faint red nebula behind it that's silhouetting it, which gives us the reason why we see it at all. So, but that's right. You're right. That's where it is.
Well, it's where I think it is.
No, you're right. That is where it is.
I don't know if I'd bet money on it or not, but.
Well, no, I think you could. I think you could. That's correct. And.
That's funny.
Yeah.
Darn, my tea is gone. Will you excuse me for a moment? I'll be right back.
I'll be right here.
Okay.
All right, now what I'll do is I'm going to bring up a view. This is now the view according to the telescope. This is what the telescope sees. So this square frame is the approximate size of the field and the approximate angle it's on, because Orion is sort of on a little angle the way the telescope is. See that? So the telescope is situated at this angle right now to the sky because it's past what we call the meridian. And so you can see that where Sigma Orionis is in here, the horse head is up there. So Sigma Orionis is here, so the horse head is going to be up here. So there we go. Hey, Tammy Sublet, how are you? Welcome to the SkyTour LiveStream. And Jane on the Journey, welcome. Sorry I didn't see you guys arrive earlier. I was in the middle of discussions with Daryl here. Now let's do something else. I don't know how this will work, but let's try it. I have a way now of taking and going to bulb setting. Sorry. Okay, I'm going to do a 1-minute shot now on the bulb setting. So there's bulb, and now I'll do a 1-minute shot at 25,600. Here we go. Sorry about the pause. I only got my voice back today. And I'm feeling rather blue. Get it? Blue. Yeah. But that's only the light. Hey, Rockstar's here. How you doing, man? We're taking a 1-minute exposure of the Horsehead Nebula with the moon out, just to see that we can get it. Okay, it should be right about here. Like we talked about before. I think that'll be pretty cool to see. Wow, that's pretty good. I don't know if you can see it. I can. I'll try to point it out to you.
Back.
Here. Okay, so as you can see, I did a 1 minute exposure, and you can see the horse head right here.
Yep.
And that's with the moon out. This, just so you understand, guys, this is one of the toughest nebulae to capture because it's dark against a very dim nebula, and the moon is only a few degrees away, but we could still capture it. That's testament to the filter that we're using for all this. So that's kind of cool. Yeah, I'm really pleased that worked out well. That's pretty cool. Neat. Oh, neat. Oh, neat. Cool. Yeah, there it is right there. Right there, see it? Can't miss it. And I guess I could probably could check out a filter a little bit with that and see if I can make that come out any brighter. Maybe not. We'll see. Let's find out. Just
when you go to Arizona, you're going to have to get a motorized filter wheel and a full complement of filters.
Oh, didn't I tell you? I already have it.
Oh, okay. Well, I guess I shouldn't be surprised.
Yeah, I have a filter wheel already, and I just have to figure out how to connect it to my microcontroller and run it from there, and it should be good. This new telescope actually has a, so to speak, a higher wheelbase, so that I can put stuff on the back end of the telescope. Because normally you put stuff on the back of the telescope, you put a camera and stuff like that. And when you go to move the telescope, sometimes that stuff can have trouble swinging through the middle because it's hanging down. But this telescope, I gained an extra 4 inches, and the filter wheel is 2. So I shouldn't have any problem.
Cool.
Yeah. And the other thing, too, is the filter wheel I have is for what are called 1 1/4 inch filters. I want 2-inch filters. So I'm going to be remaking the filter wheel in my likeness, in my own way to make this work. Yeah. All right. Well, the horse head's here, but it's faint. All right, but hey, it's there with a nearly quarter moon. We got to see it. That is a really good thing. To see it like that means it's actually pretty cool. It wasn't expected. But that horse head is this guy right down here. I gotta put the pictures up, but I actually took photos of Orion with at about this magnification out in Arizona, and I did it with but my camera with a telephoto lens only, with a little lens. I mean, the lens is only 2.5 inches across, maybe 3, and I took that, and I had a little stellar guider, that would follow the stars, mounted the camera to it, and I took the photos on the very pad that the observatory is being built on. So the first light was actually from a telephoto lens on the camera. And I have to tell you that when I went out there at night and looked up for the first time, after the pad was done, I went out there at night and I looked down at the ground with a flashlight guiding my way. I shut the flashlight off, kept my eyes closed on the pad, and I opened my eyes and looked up, and I was stunned into silence. It was so beautiful. It was dark. It was beautiful. And there were more stars than I remember from the last time I was there. And this was the winter Milky Way. I could see the Milky Way. You don't see the Milky Way in Orion typically. Okay, when you back out of this, there is a Milky Way, but you don't really see it, do you? Okay, it's very faint, but it does go through here. And part of the stuff that you see in Orion, like this giant loop called Barnard's Loop, this red loop, some of these things are not visible to your eye, but in the camera they become visible. And Barnard's Loop, of course, is visible there. You can see all kinds of things. You can see, I did 30-second photos. You ready for this? 30-second photos of this region. Okay, literally at about this magnification. I saw every detail in the Flame Nebula. I saw every detail in the Horsehead. And I'm going to upload those for you. If I don't do it tonight, I will do it tomorrow during the day. Because you need to see this. And Tara says on mild weather, yeah. Well, she was out there. She knows what it felt like, that the weather was pretty nice. For people in Arizona, I guess 63 degrees is like, big coat weather. For me, that's t-shirt weather, man. Especially considering it's like 25 here tonight. Ugh. Maybe 30. Yeah.
That can sneak up on you out in the desert.
Yeah. Well, it does. It does.
I was at a star party at the top of a mountain pass here 20 years ago. And I was running around till after midnight, and all I had on was a tank top. And when I got cold, I got really cold. Yeah, that's true. I crawled into the van to sleep and wrapped up in blankets, and I was still freezing, so I let the dog in the back of the van with me, and we had a one-dog night. I think we'll leave it at that, but that's like I know what you mean. Well, I let him snuggle up close to me, and I thought it wasn't frostbite, but I was, I was freaking cold. Yeah, no, that's true. That's true. Hey, Benjamin, how you doing? Benjamin Zavala, how are you? Thanks for coming on out. Tara says it's 65 out there right now, and in the desert it's a little chillier, believe it or not. Because in the desert, it's pretty, the winds can come off some of these mountains out there, and it has nothing to stop them. They go right down the plains, and they keep right on going. Plus, it heats up during the day, and at night, it gives off its heat for a little while. But the skies, rock steady stars all the way down toward the horizon. And for the first time, I saw the star for the first time ever. Canopus. Oh, cool. Yeah. Oh, and by the way, was it Alpha Centauri A or Centaurus A, the galaxy? Yes. Yeah, that's above Omega Centauri. Which Omega Centauri is a giant globular cluster, and right above it is Centaurus A, which is this massive galaxy with a tremendously cool, dark, central lane of dust that you can see in the telescope. Uh-huh. Yeah. So you can tell. We'll be imaging that for sure. Absolutely. Did you see Omega Centauri? I did not see Omega Centauri because of the fact that I had to wait a little longer for it to come up. And I was getting so cold in just sitting out there in this gentle wind that hypothermia was starting to set in over a period of... Remember, I was in a very lightweight sweatshirt and no gloves, no boots, no nothing. And not that I would need that out there because I'm not going to be in the observatory. I will be in warmth the entire time. But the area was so steady and rock solid, it was incredible. The seeing was phenomenal. Transparency was quite good. And I'll put these up too. I took photos of all four horizons so you could see where the light pollution that is out there comes from. And when you look to the east, okay, where the stars are rising from, there is a light dome from Phoenix that you can see. Depending on how much water vapor is in the air, which is usually very little,
then you don't see, you won't see, in fact, you won't see many stars into the eastern horizon at all. However, the southern horizon, there are two small light domes that aren't even barely distinguishable with your eyes, but with the camera it can see them barely. In the northern horizon, there is one general low light dome that comes from the town just north of us there, which is, I say just north, many, many miles north, but still you see it. And then to the west, absolutely nothing. No light dome, no nothing. Pitch black, the clouds are black against the sky. And that's the secret. You know, SkyTour LiveStream West is going to be looking at things from just eastward, slightly eastward, toward the zenith, and then toward the west. And then toward the north, toward the northeast. We can look to the east and northeast as well, but we're going to be primarily looking at the zenith and west sky and southern sky. Such a beautiful location. Amazing. And it felt bad that I got sick while I was there, you know, so that was tough. Actually, I got sick in Laughlin, probably from the plane, heading out there. But I want to say hi to Daisy and Zoe, by the way. I haven't said hi to them yet tonight, and I just always do. Hope you guys understand that I always make an effort to look who's here and make sure you understand that I say hi to you specifically. And if I missed you, it's because I didn't see you. So if I haven't seen you, write something right now so I can see you. And I will do that. I will say hi to you. So we're still this is still Sigma Orion right here, Sigma Orionis, and I am going to take us now to another place. Daryl, you got any place you want to go?
No. You know, indulge yourself, as Captain
right.
Kirk told Sula.
Yeah, that's right. That's right. Or engage number one.
Centaurus A, I have seen once in my life.
Okay.
I was really surprised when I picked it up completely by accident. That was back in spring of 1986. Halley's Comet had just come through, and it was down at about its farthest south it got before it started looping back up.
Okay.
It came across Sagittarius, and then it went down eventually into Centaurus, and then started going back up under Virgo again. And I was scanning the southern horizon looking for Comet Halley, and this thing came into view in the eyepiece. I was using an 8-inch Celestron telescope at the time. And, oh my God, it was Centaurus A, and it looked just like the pictures. You know, it was round, and it was bright on two sides, and it had that dark band going across the middle of it. And it just blew my mind when I saw that by accident.
Yeah, that's pretty
And
cool.
that was right above the southern horizon here.
Wow. I think that's really cool. Very cool. You know, I want to say hello.
You'll pee your pants when you see Omega Centauri.
I don't hope that doesn't happen because, you know.
Well, I'm figuratively speaking.
Because
you'll jump up and down and hoot and holler when you see Omega Centauri.
Well, I have to admit, I mean, many of the people here were with me when I saw the Veil Nebula for the very first time in my life. It was with SkyTour LiveStream East, and we saw the Veil here. And I was out in the observatory, and I was stunned into silence. And then I was like, I was stuttering because I'd never seen it before. And
I remember that.
You remember that? Yeah, I was just blown away, and I'm not sure I can handle how good these images are going to look from Arizona. I'm not sure I'll be able to handle it. And by the way, to answer a question for Don Kunstner, NGC 2112 is a magnitude 9.1 cluster right here in the constellation of Orion. All right, 2112, and that's the one that we're on right now. And I'm going to take a picture right now. We'll just do a quick shot. We'll do let's say 20 seconds at 25,600. We should have had enough time So for the Rush fans out there, this is NGC 2112 coming up.
All right.
And Don Kunzner is actually one of those. So am I. I was a drummer for many years. I took lessons from the man who actually founded Blue Man Group, Chris Wink. He was my teacher for 3 years. And Chris taught me some amazing things about drumming. And so I used Neil Peart, who was Rush's drummer, as a model for what I like to do. You know, following the music the way he does was really kind of just an amazing thing. So here is NGC 2112. So if anyone wants to just take a screen print of that, go right ahead. I'll have some others for you to check out, you know, and I'll be able to show you some other things. But I just wanted you to be able to see 2112 anyway. And thank you, by the way, for showing me or mentioning about Rush. There we go. And let me just get rid of...
Party on, Wayne.
Party on, Garth.
Hey.
Excellent. All right, oh, here we go. Just get rid of that. Okay, there. See, now you can take a picture of that if you want and make that something you want to check out. If not, you can just go back to the stream, find it, and grab a picture while I took everything off the screen for you. So,
no night would be complete without looking at M42.
Well, I know that. You are absolutely right. And shall I go to M42? Is that what Daryl is suggesting right now?
Maybe. Just a thought.
Yeah, maybe, huh? Of course.
I think I mentioned to you before the stream, folks, spring is coming. Spring is almost here. Orion is now in the western half of my sky by 7:30 at night. And once it gets over in the west, well, I'm looking over all the light dome of the city here, and I can't really get a good look at the nebula anymore.
Yeah.
So I have to catch it when it's in the eastern half of the sky. And it's not in the eastern half of the sky very long after sunset now.
Yeah.
Spring is coming. Winter is going away.
Yep. Okay. And guess what's coming next?
The Running Man.
Ah, you got it. Yeah. Daryl said, I want to see M42, so I'm going to show him the Running Man, which is what, NGC 1979?
Well, I know we said both of them, and they're right next to each other.
Yeah,
so.
they are. Yeah, 1977. That's the NGC in 1977. Yeah. Hey there, huh? How you doing? All right. So we'll do a 25 seconds at 25,600 for this one as well. This is the Running Man Nebula. It is a characteristically blue nebula like you see down here in the blue, right? And with our guider, should have been acquired by now. It takes about 15 seconds, so I gotta, kill some time for about 15 seconds while it acquires. And then I can come right in here and take the picture, which I'm doing now. Now again, we have the moon out, and Orion is in the eastern or western part of the sky, rather. So we aren't going to have the same type of view of the Running Man that we normally can see. I will say this: when I was out there in Arizona, all the pictures I took, almost every single one of them, had a satellite going through, and I couldn't believe my eyes. There were so many satellites that were in that sky that night. Some of that, I think, was due to the fact that I had a number of, increasingly darker skies to look in as I moved the camera around. And I noticed, like in the Running Man, I had 3 satellites going through the Running Man. I was like, wow. Then I had a guy write me, a guy named Sean from MUFON. he wrote me and sent me the video and said, "Look what I found! I found a train of lights in the sky behind each other. What is this?" You know, and it turned out it was the Starlink satellites, and he found it out on himself, to his credit.
Good for him.
Hey.
People in the astronomical community are starting to get a belly full of Starlink already.
Yeah.
And I sure am. A bunch of professional astronomers from Russia complained about him the other day, and the astronomical, the IAU, the International Astronomical Union, they have voiced, quote unquote, serious concerns.
Yeah.
And Elon Musk's little, paint it black thing with that one test satellite evidently did not work. I saw a time exposure of a whole bunch of them streaking through an astronomical image, and it was just as bright as the rest of them.
Yeah. I want to thank Hypergem for donating $5. Thank you so much, man. I'm glad you found the stream. Make sure you subscribe and enjoy, because I think that it's only getting better from here. It's only getting better, So I appreciate that you found us, and I'm so awesomely pumped that I can improve this experience for all of you. Because that's what I do, man. I just find new ways to bring this to you. And when I max out on that, then we'll just start finding new objects to examine. That'll be really cool. All right, so now, finally for you, Daryl, let's go down to
M43.
Let's go down to the piece de resistance, right? Right. As we scroll down, you see one of the very few naked eye nebulae that you can see. And that naked eye means you can see it without any kind of optical help. And it is this one, the Orion Nebula. Let's just do a focus test real quick here and bring it up a bit. All right, and I will. Okay.
There's the trapezium in the middle of the nebula.
That's right. The trapezium is a really fascinating location because among the stars that are illuminating this nebula, the trapezium is doing its fair share. And we'll take a few different photos to show you that, because it's really interesting to see how you can see the trapezium's influence and where it trails off. And there's other stars that also have their influence. But mostly the trapezium, these 4 young hot stars, are giving off a lot of ultraviolet radiation. And they're causing that excitation, ionization, and recombination thing I told you about before. And we'll get back to that. But let's just do a 20-second exposure. We'll drop to 20 seconds here. And, no, not 13, 20. And we're going to make it at less than 25,600. I want to kind of show you. We'll go to 10,000, right, for 20 seconds. And now I will show you what we get. Let me just back us up a little. Because most of the nebula actually goes down like around this way. Okay, so we see it around here. Right, and there's another little one right up here. Okay, but this is mostly what the orientation looks like. All right, kind of looks like an octopus when it's traveling through the water, if you've ever seen one. Okay, so let's do it. 20 seconds at 10,000 on M42, Messier 42, the Orion Nebula.
And I still see Bill Murray eating a Baby Ruth bar.
Yeah, right. Hey there, my daily side. How you doing? Thanks for coming and checking us out again. You're really cool, man. MTX 303. Yeah, that's true. And then we have this. Then we have the Orion Nebula, which we see right here. I mean, now you'll see there's a slight bluish haze to the image. That, of course, is simply because of the fact that we are looking at a moonlit sky in this region. Okay, and this is by far the most beautiful object this evening that we saw. You notice the trapezium is just blown right out because of the way we took the exposure. And now what I'll do is I'm going to bring us back here again, And don't worry, I'll come back. And what I'm going to do now is I'm going to change one thing here. Yeah, the temperature.
Would you call the trapezium a multiple star?
Yeah. Yeah, they're
in the
near each
sense
other.
of yes, I'm sure they're physically associated and are exerting some kind of gravitational influence on each other, but are any of them orbiting any of the other ones?
I'm not sure if we've done what's called a proper motion study. I think there has been a proper motion study done on trapezium. I mean, I could probably look it up and get the answer in 10 seconds if I wasn't doing 15 other things. Actually, you could look that up. Look up proper motion study trapezium and see if you come up with anything.
Let's see what I find.
All right. Okay.
I always say Sigma Orionis is one of my favorite multiple stars, and well, golly, it would be hard to argue with the trapezium as a multiple star.
Well, yeah, there's no arguing that because they are right in the same vicinity.
Trapezium proper motion study?
Yep. Again, we call proper motion the motion of the stars, and to astronomers, studying the proper motion tells us where the stars are going, where they're moving, and all that. Wow. Yeah. Okay, so this is really pretty, and what I want to do, just to quickly show you, and this is not the real color because we are using a filter. Oh, there's our moon. We are using a special filter, but I do want to change the color bias, shall we say, because that's something we need to do, and it's called color correction. So let me see if I can get the color correction to look a little bit more correct. It's also called color temperature. As you can see, this is now approaching the right color temperature. Okay, this is more like how it really is right here. Without the filter, this is what we got. These are it's much redder here. This area is actually a greenish blue. Okay, if you remember the Running Man, we looked at the Running Man before. The Running Man was actually very blue. This is greenish blue, and there's a reason for that. And Daryl knows the answer, and I'm going to let him tell you. Why is it greenish blue, Daryl, not bright blue?
It's O3.
You got
it.
It's
oxygen 3.
That's right. What's oxygen 3? Doubly ionized.
It's doubly ionized.
Yeah, it was doubly ionized oxygen. And what people...
It puts out a very characteristic kind of a bluish-green aqua sort of color,
yep.
And it's the same color you see when you look at planetary nebulas.
That's correct. And
like the dumbbell and
yep.
lots of others.
And for the same reasons. Because oxygen atoms are also available and freely created in some of these stars, and when the stars finally release them to the interstellar medium when they die, and go into these supernova explosions or planetary nebulae that just slough off the outer layers of the star, then you'll see this green haze around the star, and it's actually oxygen atoms that have not been ionized once but twice. And what happens is, when we look at oxygen atoms, we say, well, if it's been doubly ionized, why isn't it O2? The reason is, as with every atom, let's go back to hydrogen. Hydrogen, when it has a proton and an electron in a normal hydrogen atom, right, where everything's balanced, that's called H1. That's Roman numeral 1, so H like an I, H1. Okay? When you ionize hydrogen, and then the electron recombines later, but when you ionize hydrogen, you get what's called H2, Roman numeral 2. So see, that's the origin of that. The Roman numeral 1 refers to the base state of the atom. So oxygen 1 is an oxygen atom with all of its electrons. Oxygen 2, Roman numeral 2, is an atom that has been ionized one time when an electron is jumped off. And a doubly ionized oxygen atom, O3, III, Roman numeral 3, is one where there's another electron that's bounced off the atom as well. And so we have the O3, and that's what we're seeing here. This is O3 here, and you'll see it near the core. So these stars are very, very hot. They're able to ionize hydrogen out to a few light years, like this, and because this is several light years across. I think it was 22 light years, something like that across the Orion Nebula. Do you remember? It's fairly big. You know, it's like 20 light years across or so. So that said,
I'm sorry, I was reading.
No, that's all right. That's okay. I was just saying, isn't the distance across the Orion Nebula about 20 light years or so? Do you remember?
I don't remember offhand.
Okay.
It's big, I know that.
Yeah, but if you imagine, that means that the trapezium stars are actually bright enough and high enough energy to actually cause radiation to make the oxygen glow many light years from where they are. So you can see why, when we talk about supernovae, why they don't have to be that close to us to cause disastrous problems. They've got if they're beyond 10 light years or so, we're probably okay. But then again, there's no O stars, okay, within 10 light years of us. So that's good news for us, because that probably that'd be the only star we see.
I have an answer for you. I'm sorry.
Oh, that's fine. So you're talking about the proper motion?
An answer. Yeah, this one. Oh God, I found results going back to the early 1980s, and probably more if I looked longer. But this one is from Cornell University, 12th March 2012. All 5 members of the Theta 1 or Orion B system appear likely as a gravitationally bound mini-cluster, quote-unquote. One of the 5 members, not just 4, but 5, one of them, however, B4, is most likely in a long-term unstable, non-hierarchical orbit, may soon be ejected from this mini-cluster.
Yeah, does it tell you why? Because if it doesn't, I'll tell you why.
Go ahead.
No, I was going to say, whenever you have three stars in a cluster, for instance, then it seems to settle into an orbital state where 2 of the stars orbit each other and a third one goes around both of them. But when you have 4 stars in the cluster, unless the stars specifically break off into 2 pairs that are orbiting each other and then together as 2 pairs orbiting the common center of the 2 pairs, then you have an unstable orbital dynamic situation. And most likely, over time, one of those stars will end up being ejected from that cluster. Now, that could be happening right now. We could be looking at it happening and not even know it, because it takes so much time, something the universe has aplenty, for this to occur.
Yeah. That brings to mind, the double-double in Lyra.
That's right. Epsilon Lyra.
Are they all physically associated? 2 pairs, 2 different pairs orbiting like a common center?
I think so, but that's another look up, Daryl. If you're ready to go for it,
See what I get for asking all these questions.
Hey, look,
I'm sorry.
I don't have all the answers, but I can tell you that each single pair, of course, are gravitationally bound to each other. But the double pair, that may be. But keep in mind that isn't so much of a miracle when you consider that that's what I'm talking about. When you have a double like Epsilon Lyra, where you have a pair of 2 stars here and a pair of 2 stars far away, if they're gravitationally bound, they will orbit around the common center of the 2 pairs. But those 2 stars and 2 stars don't interact with each other directly. There's no interaction there, except for the common orbit between the 2 pairs. So they'll never see each other up close, However, think about a dense cluster of stars like the double cluster. Think of a dense cluster of stars like 2112 we just saw. These clusters have a lot of dynamic and interactions. And then, add to that, what about globular clusters? Like Messier 13 coming up. We'll be able to see Messier 13 very soon here in the season. And that has tens of thousands of stars all in close proximity. They're not just sitting there. they're all orbiting each other. They're all gravitationally bound. So
Yep.
they will often eject stars from their clusters and capture other stars when they pass through the galactic disk. So it's really they're like sort of like vacuum cleaners in a sense, but they actually do some phenomenal dynamical operations that are just fun to look at. I mean, you can actually do simulations to see what they do. I'm going to do 10 seconds, by the way, at 3200. I want to show you the core of the Orion Nebula here, just the core. This is kind of cool. Go ahead.
I guess per my question a few minutes ago,
About Epsilon.
as they said, not so much that the trapezium is a multiple star system, but it's a mini cluster.
Yes.
So, not that they're orbiting each other. They may be about a common center or something, I guess, except for that 1/5 member they mentioned. And this brings to mind, too, what you said a minute ago about, the chaotic orbit or whatever, that I have heard that said about Sigma Orionis, that, this is one of the things that I think you see in the eyepiece and not in a telescopic image unless you have the right image scale to really get close. There is some question, are all the stars around Sigma Orionis actually in common orbits, and are they chaotic orbits or whatever? There's some question of that.
Yeah. And Donald Kunzer says, I thought multiple stars would orbit a single point like a merry-go-round. Not often the case, Donald, and the reason is because space is, and I know you know this, and I'm not trying to belittle your comment, because that's actually a very good comment you made. It's that there's 3D space. It's 3D. There's no up or down, left or right. There's no plane of orbit like in our solar system in a star cluster. They kind of form wherever they do, and they're before they become stars, like the trapezium here, they are becoming dense knots of gas and some dust. And the dense gas gets more and more pressure built up on top of it. Each little, cluster of gas, in fact, gets hotter and hotter in its center as it acquires more gas on top of it. It has its own gravity. Finally, it reaches that threshold for nuclear fusion. That's around 13 million degrees, and then that starts the first batch of hydrogen to helium fusion. And that is the next phase beyond that, is when we actually have these fully evolved clusters where they actually are now in their space where they formed, like the trapezium. And there is going to be interaction here, and something's going to happen. They're going to begin to orbit each other as the gravitational dynamics begin to take over. Now, as they're forming these knots of gas that we see in the middle here, these stars, if you think of these as just knots of gas and not stars yet, they're already moving. They have mutual gravitational force between themselves, and they're already moving. Then they become stars, and now they have this radiative output. And what does that radiative output do? That radiative output causes the gas around them to be blown away, which is why the nebulas tend to look barren in the middle at the end, because the stars are exhausting that stuff. For instance, the Rosette Nebula, hot young cluster formed there. Most of the gas has been blown out of that central area of the Rosette. So that's pretty self-explanatory as to how these stars operate. Once they wink into existence, and they do wink into existence, suddenly they're there when fusion starts to work. When that happens, then all bets are off as to what happens to the gas in that nebula. And yes, Ronald, M42 is a stellar nursery. Hut says, hydrogen to helium what? Well, that's a good comment, because the hydrogen is made into helium. Well, how that works is two hydrogen atoms slam together and form actually a deuterium atom first, which is hydrogen with an extra neutron. Then the deuterium atom combines with another hydrogen atom, and that forms an isotope of helium. All right, and then the end result of the proton reaction that we call it for this hydrogen fusion is an isotope of helium. And all an isotope means is that it has more in the nucleus than it had to begin with. And it's an isotope because it's still helium. For instance, helium has 2 protons and 2 electrons. That's the base atom for helium. Now, if you add a neutron to a helium nucleus, now you have an isotope of helium because it's still helium, but it's a variation of helium. Add 2 protons to a core, to a nucleus of helium, and it's yet another isotope of helium. All right. In fact, that's helium-4 when you have 2 protons and 2 neutrons. Okay, helium-4. We see helium-4 in the regular fusion production, and we see helium-3 where you have 1 extra neutron in a helium core. So you see both of those isotopes. All right. But I just think it's pretty interesting when you look at how the fusion process actually works. There's a lot going on, and I know we've talked about it in SkyTour Radio actually quite a bit, and I'm willing to talk about it more if anyone has any more questions. And there's only 2 ways in which hydrogen fusion occurs in the entire universe, and one of them is this proton thing that I just mentioned. And there's one more, and it's called the CNO cycle. And the CNO cycle is what's called a catalytic cycle, but it operates on carbon, nitrogen, and oxygen atoms to do fusion. So I think it's pretty cool. And there's only 2 ways in the entire universe that this actually happens, and I think that's pretty cool. It really neat to follow that, you know. So just to clarify, okay, when we talk about what happens in that chain, okay, 2 hydrogen atoms come together and make a deuterium atom, all right, deuterium isotope, which is an isotope of hydrogen, has an extra neutron in the core. Then another hydrogen atom comes along, and the deuterium and the hydrogen collide and form something that has 2 protons and 1 neutron in it. Okay, that's helium-3. That's an isotope of helium. So 2 protons and 1 neutron is a helium-3 isotope. All right, and we only have nuclei here. We don't have electrons in this. Okay, but now you can imagine 2 helium-3s come together, and they actually form helium-4, 2 neutrons and 2 protons. And out of that comes 2 hydrogens. I know, confusing. In the end, it's something that basically just gives us the result we want, the result we actually observe. Okay, so we do get helium-3 as a byproduct, interim product, and then helium-4 is the final product from that. Now, add more heat, add more mass, all right, and that helium can be fused into carbon, okay, and the process continues. Nitrogen, oxygen, fluorine, okay, all the way up to iron, number 26 in the table, only for the most massive stars. And when iron is formed, it sticks like iron in the throat of the star. It can't be fused any further, and it's rather inert at that point. So an iron core really spells the end of the star. And eventually, when the star has exhausted everything else that it can make, that's when core collapse occurs. And that's when the star collapses, the core collapses, and it's all collapsing down on that iron core that we just talked about. And it just rebounds off of that. But you have to understand the energies from all the mass of the star, all the way outside the star, collapsing down on the core, generates more elements in the periodic table. generates all kinds of radiative energy of all sorts, and it totally disrupts the star. And that's the supernova, the Type 2 supernova. Just a massive explosion. And these stars here in the trapezium, well, I'd have to look at their masses, but I would suspect that all 4 of them are probably going to end up being, sadly, supernovae at some point. So this area of Orion is going to be one beautiful location sometime in the future. I know Daryl's still with us. He's probably on pause. Or he's on mute.
Not anymore.
Oh, all right.
No, no, I agree totally. I mean, it's already beautiful, and it'll be even maybe more beautiful when they blow supernova.
Yeah, and if you notice, the center part here, you'll see this central part. We're seeing this really interesting modeling here. This is, the black stuff is dust, and obviously the light stuff is gas that's been excitable. Hey, Dave Schmidt. Hi, Starseed. Thank you for coming out. And so when you look at a nebula like this modeling is the result of the knotty nature, that's in Knotty, knotty nature of the dust in these locations. And this is a part of a much bigger complex. I didn't take a very deep photo, by the way. This is actually just a very a small, low exposure photo. If we were to take a deep photo, which I'll do now just for fun, I'm going to go up to, we're going to do 1 minute, all right? We're going to do 1 minute, and we're going to go up really high. Let's say high enough because we have the moon out. Let's do another 1 minute at 12,800 on the Orion Nebula, okay? I'd like to show you what we're looking at. When we get to this, we'll check it out. So, the bottom line is that Huss says, could helium-4 be put in a balloon? Well, I don't see why not. Okay, we do have the extra mass of the neutrons. It'll be less buoyant than plain helium. But it should be buoyant enough that it would still work. Now, the moon has a lot of helium-3 in its surface crust. Just the way it all works. Yeah, deuterium H2. Yeah, and the 2. I know what you're trying to say there. Basically, that 2 should be like a little superscript, above there. Yeah, Earth is running low on helium. Well, you know what? We didn't really have a whole lot of it to begin with, frankly. Oh, really? Come on. Look what happened in the interim while I was talking. You know what that means?
I'm sorry.
You know what this means, right? When I have this here?
Oh, the dome's getting in the way?
Yeah. If you'll notice, what happened was it interfered with the guider, too. So, do you mind if I go and move the dome a little?
Sure.
Okay. I shall be right back. Hey, Tim F. Nice to see you.
I'll try to entertain people while you're gone.
You're always entertaining. Come on. This has been a great stream.
Well, hey, I'm barely getting started.
Hey, this has been a great stream, and if you ask people, I bet you they'll tell you it's been a great stream. They've really enjoyed it. I've really enjoyed it. It's been a good time. I'll be right back.
I think I'm maybe 30 seconds ahead of you folks in chat. On Mark's Skype page we're sharing, it turned red, which is usually a sign that the shutter on the dome, or the edge of the dome shutter, is interfering with the camera. There you go. But if you look at that now, can you see Bill Murray eating a Milky Way, eating a Baby Ruth bar? It's that real dark thing in the center. They used to call that the fish's mouth. Mark was talking about you could see fine clouds of dust in there earlier, and well, that Baby Ruth bar that he's eating, that's a great big hunk of dust right there.
And that's all going to be building blocks for future stars and planets. And if you don't see Bill Murray eating a Baby Ruth bar, well, maybe you'll see Hannah Youngman smoking a cigar. That's his eye toward the top and his nose to the left of the top, and his mouth is open, and he's either got a cigar or a Baby Ruth in his mouth, and his chin down below it, and that's what they used to call the fish's mouth. But hey, it's the 21st century, so I'm going to call it Bill Murray eating a Baby Ruth bar.
Yeah. And so pronounces Daryl, and so it shall be written.
Yeah.
All right, let's do this again. Okay. Kathy Persnick, thank you for coming, and I'm glad you had a good time, hopefully. And I will talk to you next time. And let's see, did I miss anybody? Anybody have questions while we went out? Dana Whitaker, I think he got a kick out of how you described the Orion Nebula.
Who, me?
Daniel Whitaker got a kick out of how you described it, didn't he?
Oh, okay. I guess. I hope. Well, if you can see Bill Murray eating a Baby Ruth, you should be able to cross your eyes a little bit, and I bet you'll see Hannah Youngman smoking a cigar.
Yeah. I was very good with animals in the clouds too, Daryl.
Hey.
You know? There we go. Okay, so this is, and as you can see, the guiding is working great. This was a 1 minute exposure. All right, so we did 1 minute with that. Was it 10,000? Oh, I didn't want to go look, but I'm gonna. Yes, it was 12,800. Yes, okay. Now we look at this, and you can see that we have a huge number of stars in here, and I like these stars, these little guys, and you don't see them yet, but you'll see them in just a minute. So move up through the nebula, right there. Because we got 1, 2, 3 stars right here. These stars are really interesting to me because they are sitting in a little area where there's some dark dust behind them, and they're actually quite visible. You can actually really see them easily.
Yep.
And I really like this location a lot.
Well, with the deeper exposure you have there, what I was jokingly calling the Baby Ruth bar, and then the darker part to the left of that, I mean, that is really quite a deep, dark cloud of dust right there.
It is. Actually, it actually extends all the way out into here, because you think of the Orion Nebula here, this whole area is like a blister. Okay, and I have to use my little thing here to show you. It's like a blister, right? This is the edge of the Orion molecular cloud here, and this is a blister forming over the outside edge of the cloud. And this is a stellar area within the cloud that is being illuminated, but it's not devoid of black, because I feel like Don Madden here. Okay, it's not devoid of the black area there, okay? There's still some black stuff in there.
Did you say you feel like John Madden?
John Madden, yeah, not Don Madden.
Very good.
Yeah.
Well, I guess you could say, again, if you look at Bill Murray's mouth, or the Baby Ruth there, or the fish's mouth, as it was called, I guess that would be comparable to like the horse head, wouldn't it? I mean, we're seeing it in silhouette.
Yeah. Exactly right. The same kind of material, too,
Yeah.
So you can see a lot of detail in here, which is really kind of cool.
Absolutely.
And, we can actually probably pull a little more detail out of this if we do the following. Let's go back here, and let's go back. Let's take this down to a lower value, and let's still do another 1 minute shot. 4,000 ISO, literally a fraction of the exposure ISO sensitivity, but we'll still do 1 minute. And I want to look at what we call the bay, okay, or that area that was dark. Not in the we looked at this before. We're looking at this area here.
Yes.
This is the bay. But let's check it out now when we can see it a little bit better. It's going to be a much darker view, more visually pleasing, I should say. Okay, but it's still going to be 1 minute. And we'll be able to check this out. Those beautiful stars up there should be really vibrant at that point, because they're lost against the blue haze of the moon. The moon's really quite bright, and right near this, actually. You know? There we go. Look at that.
Yep.
So now we move in, and you can see that one of those stars is actually red. Okay. This star is actually red. All right. And then this star is actually red. And then this one in between is actually a blue star. Really pretty. Now, what I'd like to know, and I'm asking in all sincerity, where's Bill Murray and where's the Baby Ruth?
Okay, where those two little stars are close together that you were admiring.
These two?
Okay, and then the dark cloud around them, yes. That's his eye. Just to the left of that is his nose. And below that is his lip, his upper lip. And he's sticking the Baby Ruth in his mouth.
What's this then?
What
is all this then?
I don't know.
That has nothing to do with it?
Maybe it's his hand holding the Baby Ruth. You know, think Caddyshack. That's what I'm thinking of. But yeah, you see the eye. I mean, that's sort of the profile of his face, looking from the left.
This one?
The two little stars. Yes, the two little stars you saw, and that dark cloud around them. That's his eye. And just slide over to the left a little bit, and that's his nose. Point of his nose. And just below his nose, that's his upper lip, and then down below the Baby Ruth, well, that's his lower lip. That kind of looks like Barney from The Simpsons when he belches. You know, his lips make that kind of bacon wavy motion. Do you see that?
I know. But if this is his eye, is this his nose?
That's his eye. That's his nose.
And this is
even the blue part's his nose.
And this other part here, this is like just above his lips. This is his mouth.
That's his open mouth, or you could say that's the Baby Ruth sticking in his mouth. And then just below the Baby Ruth, that's his lower lip and his chin and his jaw.
Okay, like here.
Yeah.
Why Bill Murray?
I don't know. I guess I had watched Caddyshack right before I saw that the first time. Caddyshack's one of those movies. If it's on, I watch it. I can't help myself.
Yeah, I know. Hey, get that guy, a little varmint. All right, so let me get this straight here. All right, and to do this, I'm gonna use a smaller size here. Let me just use a smaller pen. All right, so this is his face. These are his eyes right here.
Yeah, that whole dark blob that the two are in, that's his eye.
This is his nose.
Yeah, I'd go on over into the blue.
Like over in here?
But yeah, just follow the curve of that blue right there.
Like here?
Yeah. That's his nose.
This is his nose.
Yep.
Okay, we're going to clear this and try again. All right. So somehow this whole thing is his eye. This is his nose. So this is the eye. This whole thing.
Yes.
Okay.
Yeah. And there's his eyebrow above that and his forehead above that.
Up there.
And if you follow that line down, well, that defines the bridge and the point of his nose.
Not this line, but this line.
Yes.
Okay, so this
is the line again between the purple and the blue.
This is his forehead. This is his witchy nose.
Okay, and then that top curl, that's his lip.
Right here.
Yes, that's his upper lip.
Okay, and his mouth is open.
And his mouth, and there's a baby Ruth. And then
Okay.
down under that, going back toward his chin to the left, is his lower lip.
I
That
guess
Barney,
that's
Barney
the-
from The Simpsons lower lip.
Or is that this right here?
Maybe it's Barney eating a baby Ruth.
Wow.
No, I'd go farther down for the lower lip.
Down here?
Yes.
And so this is the upper lip here, the Barney lip, that kind of thing.
Yeah, well, they got that look to them, when Barney belches and his
Yeah,
lips curl like that.
Yeah. I look a
they
peanut.
flop around.
Remember when he got dumped in a barrel, and then you hear brap, and he goes, "Hey,
Yep.
look, a peanut! Hey, Homer, look, a peanut!"
So we discovered another one tonight.
Yeah,
We've strayed far from the field of science tonight, folks. I apologize.
Yes, and then they go this way and go that way, and then end up here. That's one eye. That's another eye. And now we have the attack of the weird cat people. Okay, enough of that. That's just crazy. Wow. Well, that was a new one on me.
You don't see a face in that.
I sorta, kinda, maybe.
I mean, it's profile. He's facing left, and he's belching or whatever he's doing. Let's call him Barney.
Okay. Barney belching. I mean, he looks like, actually, more like Beavis from Beavis and Butthead.
That could be too, yeah.
Yeah. I belched a nebula, Beavis. Butthead.
There you go.
Shut up, Beavis. You're a dumbass.
Sorry, folks. Once we get started, it's hard to stop.
Yeah, well, that's what happens, when astronomers are recovering, This is what we do. Well, anyway, I think it's beautiful, don't you think, guys? I mean, I think that's pretty.
You'll never look at the Orion Nebula the same way.
I'm always going to see Beavis now.
There you go.
Yes. All right, well.
Oh, this is funny. I'm sorry. I think I ruined the stream.
You did not ruin the stream. You probably gave it the highlight of its night. There's one more thing.
We see things in the sky. You look at the Dumbbell Nebula, and it looks like an apple core to me.
Yeah. And now I'm going to go one more thing, just by the way, just so you know. All right, we're going to take off here. And now we're going to Saif, I believe. Yep. And then from there, we're going to go to this guy called the 13th Pearl Nebula. We'll see what this looks like.
I can hardly wait.
It's also called the rubber stamp. Remember this?
That rings a bell.
No, that's the dumbbell, and that's in the summertime sky. Come on.
Well,
just kidding.
That's in Amanda's favorite constellation, Vulpecula, the little fox.
Yeah. Donald, you're right. There's a lot going on in Orion, without a doubt. So let's come back in here now, and let's take care of doing a visualization of what is in this location. And we're just going to go up to say, I actually took an exposure, a deep exposure of this area, and there was no more here than we're going to see here in just a 25-second shot, or even a 20-second shot. So let's do that, and you'll see it. Here we go. Acquiring, executing. All right, here we go. Tim F. asking me when I got home from Arizona. I got home from Arizona. When did I get home from Arizona? Last Wednesday, I flew back. It's such an easy flight, let me tell you. You know, really, really nice flight. Well, there we go. This is the 13th pearl. You can see this really interesting look to it, called rubber stamp because of this black.
Okay, I remember that now, yeah.
This black dark nebula, which is actually dust. And this star is illuminating this. And it's a reflection nebula. It's not an emission nebula here at this point. But you know what's funny? The other night I took an image. I was doing a private stream for myself. Not even a stream, but just a private viewing, doing some research. And I was acquiring images of Hubble's Variable Nebula again, because I wanted to see if it looked different. And apparently I caught it at a point where it looked just like one of the other times we took a picture of it. And I will bring that up. I want you to see it, because I do have,
Wow.
Yeah, you see it. Now I'm going to bring it up for everybody else.
That's very nice.
Yeah, that was... Hubble's Variable Nebula is notoriously small, but with this telescope we actually get to see it a lot bigger. It's really quite nice. So Daryl just saw it, and I'm going to show you guys now. Let me see. Is this the one that's going to show it? Yes, look at that. This is Hubble's Variable Nebula, and it's really got a quite a lovely look to it. Okay, and last time we looked at it, we saw there's an area in here that was devoid of material. But then there was one time when we actually saw this had an illuminated area in here, which told me that the star that's causing this, which is not visible to your eyes, was actually illuminating that part of the nebula. All right? So, again, this is dust. And we're looking at a reflection nebula, basically, scattering. The dust particles are scattering the bluish light to us. But they're also reflecting a lot more than that. Or otherwise it'd be very blue. But isn't that pretty?
It is. That's beautiful.
Yeah. And so...
I think you can tell over time. I don't remember that. I think I remember that darkest part.
Yeah.
But, I mean, it's just everything is shaped different now.
Well, what I did was...
it's really something.
I took a deeper shot, and look, you can actually see there's an additional piece here coming up. That's something that we hadn't seen before, this little extra piece going up like that. This was there, for sure. I took a picture of this in a 20-inch refractor. The photograph was probably like 6 seconds long, and the photo of this object was really it was even smaller, which is kind of weird because the telescope had like an f/22 focal length, maybe more, maybe f/40. It was just crazy, but that's really neat, Yeah. And now one of our eagle eyes, Daniel Whitaker, asks, what is the bright star? So is the bright star... Wait, what's he saying? So is the bright star between it and us? Yeah, okay. Good question. This bright star right here, believe it or not, is not responsible for illuminating the nebula. It's just a line of sight item. Okay? So that star right there. Interesting thing. People think, oh, this is illuminating this whole thing. It is not. It is not.
Sure, it looks like it, though.
Yep.
Yeah, and I know, you get chance alignments all the time.
Yeah.
Looking out in space, because, as you said earlier, space is 3D.
Mm-hmm. That's right. And Ronald says, looks like a comet. Yeah, it does. It does. But there's a bit of a predilection that you might have to thinking that this star is the thing that's the head of the comet and that's trailing behind. And nothing could be further from the truth. The universe throws curves at us every which way we turn. So that's why I don't expect that people would totally get that, But this is the Hubble's Variable Nebula that I took the other night. And you can see, when I take the time to do things for me, and thus for you, then they end up looking a little more detailed because I take the time to not just do the quick processing we do when we do a stream, but actually do the processing that takes, a little over an hour to get what you see here. And that was kind of pushing it. I sort of rushed through it. Anyway, so what's closer is the star here. I actually believe that the star is a little closer to us than this nebula. Donald. That was a good question from Don Kunzler. So that's part of the thing that's interesting about this is that these line of sight dilemmas cause these things to happen. But I think that's pretty neat. Hey, Papa Tom. Where were you? I didn't see you before. Now you showed up. All right, man. It's so good to see you. Thanks for coming out. We're having a good stream tonight, I think. Hopefully I'm not, wrong about that. Hopefully you guys think this is pretty cool. I'm enjoying it. But now let's go back. Let's go back to our view. This is the view we're looking at. This is actually the rubber stamp nebula. We got there when we talked about this is a reflection nebula. You can see a little additional stuff around here at the starting, but that's very hard to find, especially with the moon out. But, this nebula is neat because it has a number of things going on. This part here is reddish a little bit. It might be an emission nebula coupled with reflection nebula. All right. And dark dust that is obscuring what's behind. All right. And that's the rubber stamp nebula. So I hope that you enjoyed the rubber stamp nebula as I love being able to stamp it out for you. Now, let's see what else we have. There's always so much to see in Orion. Did you know there's a galaxy in Orion?
Hey, I've heard that. I don't remember where offhand.
Yeah. It's IC 421. It's a magnitude 12 galaxy. And I'm going to see if we can see it. You know why? Because I can. I'm kidding, of course. Let's see if we can see it. I'd like to see
it. To your telescope.
Well, maybe, but still.
You know what you're doing.
Yeah.
Go for it.
I know what I can do, and let's hope I can do it. Now, it's probably going to go over to SAFE again as a structure. Now, I'm doing a two-part find for all these things when we do this, okay? Oh, it's going to Rigel. Okay, yeah, there's Rigel, by the way. It'll be here for just a few seconds. What the telescope does, to those that want to know, is the telescope finds a known bright star in the area, and it doesn't have to be as bright as Rigel. It could be like this star over here, very faint. Then it moves exactly where it has to go to find these objects, and it will put them right in the middle of the view. All right, so it's pretty cool. Now, I expect that because Rigel was at the top, that the galaxy is going to be kind of at the top too. So let's hope that it catches on. It catches what we're trying to do. And I would go up to 25,600, even though the moon's out. Trying to look at galaxies and things when the moon's out is not a good idea. But I'm just trying to see if we can do it. All right. We should be ready. 25 seconds at 25,600 ISO.
Whoops.
Daniel Whitaker, you have a knowledge of astronomy, my friend. Lowell is spinning in his grave. And you know what? 100 years from now, people will look at what we did on SkyTour LiveStream and say, wow, can you believe they use such simple tools? And yes, We can believe it. Okay, I'm looking for my galaxy. Yeah, I don't see it.
I see something kind of fuzzy just right of center.
This guy?
Maybe a little above center. No, that one right there. Don't know if that's it or not.
Where were you looking?
Yeah, you just circled it.
Oh, you talking about this thing?
No,
this?
go up one.
That.
Now it looks more. Yeah, now it looks more like a star.
Yeah.
Sorry.
No, that's okay. Okay, I can see the focus is off just a little bit too. Wait, no, it might be this. I don't know. I see a little fuzz there. Trying to find things when the moon's out is crazy, especially when they're at low surface brightness like these. But it's okay. You know, we're having fun trying to find a few things. Let's go now and see what else we can find.
May I ask?
Yes, please.
Down to Rigel. I don't know if Stellarium will show this. And okay, yeah, I see the cloud. To the right of right there, the witch head.
Mm-hmm.
Have you ever tried that? I know that's quite a large object.
Yeah.
Your camera's on the scope is probably you could probably only catch a little bit at a time. Have you ever tried the witch head?
We have actually, even in SkyTour LiveStream, but it didn't show up because it is a low surface brightness and it was filling most of the field. This red square is actually a little larger than the field. So you can imagine when we take a picture of the witch head, we're actually looking at a much smaller square. So the witch head encompasses the entire field. So unless it's a very bright piece, we're not going to see it. You know, we're not going to see it too well. And this has to be captured with a wide angle view.
That's what I was thinking.
Yeah. So, and tonight, of course, with the moon out, let me show you how close the moon is. Okay. Let's just look over here.
I'm sure the moon would probably wash that out.
Oh, yeah, totally.
Yeah.
See? It's really just right there.
Yeah.
Yeah. So the fact that we can see the Orion Nebula as well as we can is, of course, testament to the fact that we're looking at a very, very bright nebula. Yeah. All right. Actually, you know what? Let's think about this now. We did all this. I'm actually at the point where my voice is almost talked out for tonight. I gotta preserve it. Yeah, so I'm gonna have to just try and find one more object that we can look at.
Just one more.
Just one more. The rosette won't show too well. Actually, let's see if we can do Hubble's Variable Nebula. Oh, I just showed you. Let's see if we can look at Hubble's Nebula. I'm not sure if we'll get it because the telescope dome may not be in the right place. If it's not, I won't be spending the time to move the dome tonight. Once we have a roll-off roof observatory, nothing is out of the question anymore. Okay, now we're going to Alzir, and then we'll just pop down to Hubble's Variable Nebula. Actually, it'll be fun. I'm going to do a 25-second shot right now. I'm taking a picture. So we're going to catch all the stars zipping through at 25,600. And then it's sidling up to the Hubble's Variable Nebula. It'd be kind of fun to see what we get. This will be like art, like a piece of art.
May I ask while you're exposing?
What am I exposing?
I said, may I ask a question while you're taking your shot there?
Of course.
I assume you've done this. Have you? Wow.
Isn't that cool?
What is that?
That is what I did. I did a piece of art. I was actually I was exposing while the telescope was moving. And there's Hubble's Variable Nebula right there.
Yep.
And there.
Okay.
Yes. What was your question?
What camera are you going to use at SkyTour West?
I'm debating. I haven't bought it yet. I'm actually when I buy
I mean,
it.
more of a dedicated astro camera or a DSLR or I mean, you're still using a DSLR here, I assume.
I am, and I think I'm gonna still use it out there. A camera like it. I'm debating right now about getting the latest version of the Sony camera that has, because this has like 20 plus megapixels, and the camera I would get would have over 40. But I did an experiment. Actually, I created this diagram here. I'll show you the camera here. I don't know if it'll show up well, but this diagram is a resolution diagram, all right? And you use it to determine resolution of your cameras. And I took two pictures, one with the new Sony that I had here, and one with my existing Sony. And the difference was so minuscule, I couldn't tell the difference. Yeah. Only at really high power could I notice any difference. And it wasn't even substantial. Well, there's Hubble's Variable Nebula now, tonight, right now. This is a live photo we just took. And as always, as I've said before, if you take a look at anywhere else in the field of view, you can see little tiny red stars. Like we've got one. Let's see, we've got one right here. Okay, inside there. This is an orange star. Okay, and we certainly have another one up here. And if you keep looking, you'll see more like these two. Okay, and it goes on and on. So we actually have a lot of these little red stars everywhere we look. And as most of you know, I really love these things called carbon stars. Carbon stars are bright red. I mean, unearthly red. And that's mostly because there's a lot of carbon atoms on their surface. Hence the name carbon stars. And it's because it's been dredged up from the interior. These are red giant stars. Very low temperature, but really distended in size. You know. So, very cool. Okay, well, I have said just one more in the past, haven't I?
Have you said that before?
I probably have.
Probably, maybe.
Yeah. Yep.
Are you feeling like just one more tonight?
Oh, I don't know. Maybe.
I mean, I heard your voice cracking a while ago.
Yeah. It's still not quite comfortable. I know I could look at the rosette, but again, the rosette doesn't look very nice. Except, you know what? Okay. We're going to go look at the rosette. I'll tell you why. And this will be the last item for tonight. And I'll tell you why we're doing it. We're looking at the rosette because it's really a stunning cluster. And that cluster has a nebulosity around it. And maybe with the moon, we can try and see if we can see some of the dark dust lanes associated with the Rosette Nebula. I took the pictures of the Rosette with the camera, by the way. 30-second shots with complete detail of the Rosette out there. It was stunning.
Cool.
This is the interior cluster of the Rosette right here. And the Rosette's pretty extensive. Really?
The Rosette is a is another one that it may be hard to see the nebulosity by eye, but it photographs wonderfully.
Yeah.
I know I caught the Rosette way back in the days of film.
Did you?
Taking pictures of Orion constellation.
Mm-hmm.
And the Mason Nebula of Orion's head comes out well also.
Mm-hmm. Now you may wonder why I'm doing this, and it's because I happen to know where one of the more interesting spots in nebulas. It's this section here, the northwest side of the rosette. The rosette, think of it as a big sphere going around all this. Okay, so let's do 25 seconds at 25,600 with the moon and see what we get. Tara likes my artwork. Hey, I'll do more. That's actually kind of cool. Start a thing. Daniel, to answer your question, what I just saw, no, I won't be able to see Proxima, unfortunately. It's going to be too far south. Not by much. It's going to be just terribly close. You know. Well, look. The dark lanes seem to come out okay. You can actually see them here. See that?
Yes.
These are the dark lanes within the nebula. And you can see some of the red nebula here. This is with the moon out, guys. This is actually pretty good. Not bad. All right. Not bad at all. You can see a lot of it there. And then the young cluster there. Wow. Let me tell you, this same shot done out there, oh, I should just stop talking about it, you know, because it's just going to make people say, well, show me already. And I agree with them 100%. Oh.
Huh.
But hey, it's okay. Well, folks, I want to thank you for coming out tonight. I really had a great time with you out here. We had a wonderful time. I love showing you these objects tonight. Daryl did too. I'll leave you with the Hubble's Variable Nebula from the other night. And I think that one of the best things that we can do, what's happening there? I think that one of the best things we can do, I don't know what just happened. Oh, wow, something wacky happened there. Is to take repeated images of Hubble's Variable Nebula so you can actually see the variations in the nebula. Now, we just took one. I know, I said I'm leaving, but I got one more thing to just do. I'm not going to do anything but just show you something. Okay, there is Hubble's Variable Nebula. See that naughty nature in there where you can see the naughtiness inside there? Let's go back now. And let's go back to our view. And I just want to go back to our view and see that nebula one more time. All right, let's see now. How does that look as opposed to this? Let me just zoom us in a little bit. Now, it's not exactly the same level of detail, but let's see how it compares. Okay, that is the other night.
I think that's a great picture.
Thank you. I'm very pleased with that picture. Came out pretty good.
Yeah, I know. Looking at it earlier when you zoomed in some, that looked almost like a dark arrowhead.
Yeah.
In the nebula, kind of a big wedge shape.
Yeah. Well, just so you know, that started life as one of these images. Okay. What I did was I actually took a series of images. But you can see that dark area there. That's pretty much the same. They're not exactly the same size. But that's pretty much yes.
This one's a processed image, I assume.
Yeah, it is. It is.
Yeah.
All right, so if I take that now and I compare it. Okay, that's more like it. Now just move this over a little. Now we should be able to do a comparison. And this is actually a good way to look at this versus this. Let me just move that down a little. Maybe that's about right. You can see that there we go. Look at that. Now you can see the difference between a processed image, right, and the raw image. This is what I get naturally with the telescope. But then I'm able to process it and make it look like what it really looks like. Big difference, isn't it?
Yeah. It's impressive.
Much different, yeah. So we can see that there's some interesting details here. Okay, it might be light shadow. They could be shadows actually, because it changes so quickly that you can actually see the shadows like one night to the next.
Yes.
And in this one, the shadows are not there. You know, there's no shadows here. There's no spiky shadows here and here. And if we go back to our view, we see that we actually have some interesting shadows there that we just don't have. Yeah, pretty cool, huh? So
It is.
process versus, unprocessed versus processed. Yeah. Anyway, cool. That's a neat thing to leave it on. So I want to thank you guys for coming out. Daryl and I, of course, had fun. I'm sure Daryl would agree.
Oh yes, I've had a fun time. Thank you for having me on.
Of course, you guys are fantastic out there. I want to thank you all for coming. And I'll keep you posted on what's happening next and when we're going to do this again. Obviously, it'll be the next clear night. You know? And, yeah, you guys are the reason I do this. All of you.
Yay, Mark.
Yeah, well, yeah, you. Come on. You know, you're part of this now.
Hey. Folks, good night, and thank you for coming. I hope I wasn't too dumb tonight. I would have written more in chat, but my my system is really lagging, so I'll just say good night. Take care and have fun.
There you go. That's such an easy sign off. Why can't I just never be so? Why can't I ever just be simple? I'm not simple. I've always got to add all kinds of stuff. You know, I'm telling you, I'm just nutty. Anyway, you guys, you have a good night. Thank you for coming to SkyTour LiveStream East with Daryl and I, and we'll be talking to you again. Bobby Burgess, I didn't even see you show up. And A14, actually. How you doing? If you guys have any questions, you can leave me a message at skytourradio@kgraradio.com. That's skytourradio@kgraradio.com. If it's for Daryl or Amanda, let me know, and we will certainly get back to you. Chris Baker, what's happening? Thanks for stopping by. So, that all said, and Moonlight, thank you. See, now they're coming out of the woodwork, the ones that didn't leave a message before. I'm glad they're doing it, though. So, it's nice to see them coming out. You guys have a good night, and Daryl and I will see you on the next SkyTour live stream. We'll talk to you later.
Take care. Have fun.